Good morning, all. Am I audible?
Yes, you are audible.
So we have total 109 participants right now. We have crossed 100 participants. So I guess we can start, sir, with your permission.
Yeah, sure.
Okay. So good morning, all. So on behalf of all the E and ICT academies at IIT Guwahati, NIT Patna, MNIT Jaipur, IIT Roorkee, IIT Kanpur, and IITDM Jabalpur, I welcome you all in this second week of 2-week online joint faculty program on Internet of Things and Application Smart Systems. So today is the 6th day. So today's first lecture will be carried by our first expert, Dr. Argadeep Roy sir. So we already know him as he has taken one of the lectures in first week. So I welcome you, Dr. Argadeep sir, again in this platform for the next lecture, sir. Over to you.
Thank you for the kind introduction. Good morning to everyone. So today, in the last lecture, we talked about some communication technologies in IoT. They are like different positive and negative aspects, such as NB-IoT and LTEM. So in some scenarios, we have seen that in some scenarios, LTEM is better than NB-IoT. In some scenarios, they are not. In some scenarios, the other one is better. So basically, in the last talk, we had an overview of communication technologies. Today, we will see that how these communication technologies can coexist with existing cellular communication, and how they can be instrumental in different applications related to smart home. The smart home is a very new terminology that is very popular nowadays. So in today's talk, we will see that how the technologies that we have uh, described in the earlier talk uh, can be optimized, can be applied in an optimized sense in the smart home context. I am Argadeep Roy. I am an assistant professor in Mehta Family School of Data Science and Artificial Intelligence, IIT Guwahati. So this is the brief outline of my talk. First, I will give an introduction, and then I will provide background and motivation of the use case that we consider today. After that, I will talk about the system model and the assumptions and system optimization, followed by results and conclusion. So, so IoT home automation aims at controlling home appliances by using electronically controlled devices. So what we mean is that in today's network, in today's scenario, you can imagine a home where different sensors are deployed throughout different corners of the room of the home, or you can consider it uh, as a smart home. And an extension of this can be called a smart city, where different smart homes exist, and then these smart homes together comes under the umbrella of a city, which can be called a smart city. So the main idea is how can we control the automation devices and home appliances using some electronically controlled devices. Okay. So, for example, room heating, lighting systems, alarms, home security control, so on. So, for example, there is a sensor in your home which monitors the temperature of your room, and when the temperature of your room is below certain threshold, and then this room heating is automatically started. I mean, room heating automatically is triggered. Basically, yeah, that is one of the application. Similarly, there is lighting systems. For example, if there are 3 rooms in your home, and then you are spending a lot of time in a particular room, the other room light is on. Typically, that leads to a lot of energy and cost wastage. But if you have an IoT sensor, it will kind of intelligently discover that the room is not occupied by people, so the light will turn off automatically. You may have seen in your campus also that when you are walking on the street, sometimes there are lights which gets turned on and off. So whenever the lights are off and whenever you are in the vicinity of the lamppost, the light gets turned on automatically. Okay, so these are some of the basic examples and related in the IoT context. but they can be made, their behavior can be made much more refined and optimized if you follow, if you just collect the usage, if you just take the use case and then formulate it as an optimization problem and then see how it can be controlled in an optimized manner. Okay, so smart home is basically IoT sensors deployed in home that are controlled using automation or intelligent algorithms. So today's talk, we will see how we can control such use cases using some optimization algorithms. Okay, some of the features of this kind of automation are basically energy saving, environmental benefit, and better security. Because definitely, as you see in the case of lighting system, it leads to a lot of energy saving because when the room is not occupied by people, the light gets turned off automatically. Okay, so similarly, there are environmental benefits also, as uh, this energy saving uh, basically leads to environmental benefit, green solutions for your smart home, and better security also. So you can sort of implement some IoT sensors in your home, in your door, and then that might signal you real time whenever there is a intruder or some unusual activity happens. Okay, so that way you can obtain better security also using IoT sensors. Okay, so here we are considering a smart city scenario where there are smart homes, as you can see, and then there are different electronic devices such as mobile and TV and so on, and they can be controlled using something called mobile edge computing server. Okay, so this black thing that I am circling over, this is hovering over, this is known as mobile edge computing server. So what is the purpose of mobile edge computing server? Sometimes it happens that whenever a task arrives at a IoT node or IoT device, and the task might be very heavy. Hmm. Or it might consume a lot of time if it is executed in the IoT sensor, right? Because IoT sensor has limited battery capability, limited processing power. So for that purpose, what they do is sometimes if the task is very heavy, that task may be offloaded to some cloud computing center, which is situated somewhere far, right? So, but the problem is every time offloading this task to the cloud computing center might be also very power consuming because the cloud computing center might be situated somewhere far. But again, there is a trade-off involving power and computation time because the cloud computing center is typically a high computing, high performance computing center, and therefore it has a lot of computational capability. So once you offload the task to the cloud computing center, it might actually get executed very fast. Okay, somewhere in between is the mobile edge computing server. Okay, so mobile edge computing server is basically placed at the edge of the network, and it is not very far in terms of distance, and then basically you instead of offloading the task to the cloud computing center, you might offload it to the mobile edge computing center also. Okay, so that will lead to some power delay trade-off. So in smart city, typically this mobile edge computing infrastructure is present, and you can offload your task either to the nearby mobile edge computing center or to the faraway cloud computing center. Obviously, since cloud computing center is the strongest form of computing, therefore the processing time will be least. In mobile edge computing server, the processing time will be somewhat more than cloud computing, but obviously it will be less than if the task is processed in the device itself. Okay, so this is a smart city infrastructure where there is mobile edge computing servers as well as cloud computing infrastructure. Okay, so, so there are two major technologies that we are considering in this talk. One is mobile edge computing, as we have explained in the last slide, that mobile edge computing is basically somewhere in between cloud computation, which might be power intensive, and in-device processing, which might be uh, computation and time intensive. Okay, and there is something called spectrum sharing. What do you mean by spectrum sharing? Spectrum sharing means that the cellular devices, they typically operate in something called license band. Okay, And there are technologies like Wi-Fi, which again operates in unlicensed band. So now these two bands are separate. Now, when the spectrum for two technologies are same, basically, if I am kind of allowing Wi-Fi device also in the cellular spectrum, or I am allowing cellular devices in the Wi-Fi spectrum, then they basically share the same spectrum. Okay, so this is known as uh, spectrum sharing. You might have heard about something called LTE unlicensed. Okay, so LTE typically operates in licensed bands, but there is a version of LTE 4G which is known as LTE unlicensed, and that operates in unlicensed frequency band. So when there is a LTE unlicensed frequency band and a Wi-Fi communication system, then it may happen that both of them are sharing the spectrum with each other. Okay. So we are considering in this talk that IoT network does not have access to the licensed spectrum. Okay. So again, this may not hold true always, because there are, as we have discussed, there are IoT technologies, for example, this LTE-M or NB-IoT. Those typically have access to the license spectrum. They operate in the same spectrum as that of the LTE or 5G. As we have seen in the last lecture also, there are different modes like in-band mode, guard-band mode. So those typically operate in licensed spectrum. But there are other IoT services also, for example, LoRa and other IoT, which does not involve cellular communication band. Therefore, they may operate in some other frequency band. We are considering those kind of networks in this talk. So we are assuming that IoT network does not have access to the licensed spectrum. So what we are doing is we are offloading. We are offloading the task with the help of spectrum sharing. Okay, so what is going to happen is there is a cooperation between the IoT network and the license spectrum. Okay, so what is happening is basically the IoT network are operating in the unlicensed band, for example. Now, in the unlicensed band, there is no quality of service guarantee, right? Because this is contention based. If you consider Wi-Fi is a contention based system. So each of the Wi-Fi access points are throwing data to the access point, and then it may happen that both of them simultaneously transmit, they collide, and both of them remain silent and goes for an exponential backoff. Okay, so these kind of situations are not ideal when you want to guarantee certain quality of service. By quality of service, what we mean is like delay guarantee or throughput guarantee, something like this. But in cellular spectrum, definitely there is a quality of service guarantee, because cellular network operates in a centralized mode. Okay, so there is a base station which basically allocates resources to the users in a TDMA fashion or FDMA fashion. So therefore, some quality of service guarantee is there. Now, IoT network thinks that okay, if I can take up the cellular network, cellular communication technology band, then I might get some quality of service. Again, cellular network thinks that okay, there are some of the devices which are present in the vicinity of the cell edge, and I am not able to give them good throughput by if I operate alone. Therefore, I might take the help of IoT access points to act as a relay. Okay, so this is kind of a structure where each of the network gets benefited from one another. Okay, so the IoT network gets benefited by accessing the cellular spectrum, so that it will get some quality of service, and the cellular spectrum gets benefited by using the IoT access points or the mobile edge computing server as a relay. Okay, so by using relay, it can offer better throughput to the cell edge users. Okay, so that way they are helping each other. So here we are considering this mobile edge computing and spectrum sharing are coexisting with each other. So up to this point, if you have any questions, please feel free to post in the chat. Because this is the basic philosophy behind the algorithm that we will develop in the upcoming slides. That these two technologies are helping each other in helping each other by like offering the cellular spectrum to the IoT network, and the IoT network is serving as relay to cellular communication. I don't see any questions. I'll wait for another minute and then move on to the next slide. Okay, so now as we see, there's a license spectrum network. What it wants to do is throughput maximization, because it wants to offer better throughput to the network that are present in the edge of the network. And the IoT network, what it wants to do is you want to task computation rate using license spectrum. So if you use the license spectrum, then you are getting some quality of service guarantee, and that will help in achieving good task computation rate by using the license spectrum. Okay. So the motivation is, in modern technology, there are large number of devices with huge data requirement, and there are computationally intensive applications as well. Okay, so large number of devices with huge data requirement, and they have computationally intensive applications. So we are proposing two questions. Okay, one is how to accommodate increasing number of devices and data requirement within a limited spectrum. Okay, so the spectrum is limited, and just a second. The spectrum is limited, and the number of devices and their data requirement is also diverse. So how to accommodate them and how to maintain latency requirement for computationally intensive task. Okay, so these are the two questions that we are posing, and the answer is handshaking of spectrum sharing and MEC technologies. So if the spectrum sharing and MEC technologies are handshaking with each other, then we can accommodate many devices within the limited spectrum. Also, for the IoT devices, latency requirements are satisfied because you are using cellular spectrum that will give you quality of service guarantee. Okay. So there is a typo here. It should be computationally intensive. Okay, so IoT nodes may operate in an unlicensed spectrum. However, that will lead to uncontrolled interference because of the contention-driven nature. And license spectrum interference can be controlled by scheduling. Okay. So the exclusive allotment of IoT spectrum for IoT network is not feasible. Okay, because in the IoT network, you cannot like just apply license spectrum. It's not feasible. I mean, the standard basically does not allow it. That you cannot unlicense spectrum without any agreement or without any standard driven thing. You cannot just allocate a license spectrum for IoT networks. Okay, but the thing is, we are proposing what we are proposing is we are doing a license spectrum sharing. That okay, I am going to use the license spectrum, and I am going to offer something in return to the license spectrum as well. What is that? That this Wi-Fi IoT access points or the mobile edge computing server will be accessed as a will be used as a relay for the cellular communication technology. Okay, so MEC partial or binary offloading to the MEC server. So basically, since the IoT devices can offload their task to the MEC server, and that is getting used as a cellular in the cellular spectrum. So therefore, that will typically guarantee certain quality of service, and the MEC and the IoT cellular network will use the IoT AP or the MEC server as a relay. Okay, so this is known as cooperative relaying based cellular spectrum sharing for IoT. Okay, yeah. Okay, so the system model is like this. The cellular network is called primary network, and the IoT network is called the secondary network. Okay, so primary transmitter and primary receiver is in the cellular network, and IoT node and access points are integrated with the MEC server. So the IoT access point is basically the MEC server, and there are IoT nodes also. So IoT nodes and IoT access point or the MEC server is one network, and there is another network which is cellular network. There is a, we are considering a primary transmitter in the cellular network and a primary receiver. So one receiver, one transmitter in the cellular, and there are multiple IoT nodes as well as a IoT access point or the mobile edge computing server in the IoT network. Okay, so this is the system model. Okay, so there are n devices, n number of devices, IoT 1 to IoT n, and this is the IoT access point or the mobile edge computing server, and this is the cellular network. So there is a primary transmitter at the base station, and there is a primary receiver or mobile phone, but they are very far from each other. Okay, so if the PT transmits directly to the PR, the quality of the signal will not be good. Okay, so the idea is you use this path as well as you use this path. So you transmit the signal to the IoT AP as well. IoT AP is comparatively nearby. So IoT AP decodes the signal and then it forwards to the PR, primary receiver also. So primary receiver is basically getting the signal from two paths. And obviously from two paths, if it combines the signal using some combining techniques such as maximal ratio combining, then it will give better throughput. Okay, so this is the model. So cellular and IoT network, there is a single transmitter which is known as PT and the receiver which is known as PR. Okay, so IoT network does not have access to the cellular network. So the IoT AP helps the PT in relaying the data to the PR. So IoT AP is basically acting as a relay. So the data from PT is coming here and then going there. Okay, so this is known as cooperative relaying because the channel condition between PT and PR may be poor. And the primary network allows the IoT network to access the cellular spectrum. So the IoT AP is basically now it can operate in the cellular band, and you can offload your task fully or partially to the IoT AP using cellular licensed band. Okay, so so basically both the primary and the IoT networks follow certain synchronized time slot structure. What is that? This is the communication which is happening. So, so this is the overall length of a slot, capital T, and then we are dividing it into four parts. The first is basically the primary transmitter broadcast to the PR and the IoT access point. Okay, the primary transmitter is broadcasting the data to the PR as well as the IoT access point within this tower by two time. Okay, for the next tower by two time, IoT access point relays to the PR. So basically, if we go back to the diagram, for the first tower by T, this thing happen. This blue arrow and this first arrow, these two things are happening. And for the next tower by T, this arrow is coming into play. So PT broadcast to the PR and IoT access point, and IoT access point relays to the PR. And after that, the next, like the remaining time is divided into two operations. One is TDMA offloading by IoT nodes. So because IoT AP is operating in the cellular mode, so it can operate in a TDMA mode. Therefore, it can schedule this, divide the entire slot into n lengths, and then give each of the chunk to one of the IoT devices. Okay, and then partial computation at the MEC, parallel computation at the MEC server. So once the MEC server has received all the task, then it computes it. Okay, so in that sense, there is no like overlap between these phases. Okay, so these phases happening in a manner such as there is no overlap between them. Okay, so we are following a synchronized time slot structure for both the network, and the slot duration is less than coherence time. So coherence time is basically the time for which the channel gain remains fixed. Okay, so we are assuming the slot duration is less than coherence time. Therefore, within a slot, the channel gains remains constant. Okay, so this is an assumption. And IoT nodes tasks can be partitioned into bits, and then they are offloaded to the IoT, to the basically the IoT access point or the MEC server. Okay, so now what is the relaying rate of the primary network? Hmm. So primary network is following certain strategy which is known as decode and forward relaying. What does it mean? It means that basically, when the data comes to the IoT access point, then there are two operations. First is decode. Okay, and then it is forward. Okay, so decode and forward. So initially the data that is sent to both of them that are decoded here, and after the decode operation is done, the data is forwarded to the peer. So, so this is the primary transmitters rates. Okay, so this BW is the bandwidth and log2 of 1 plus SNR, as you know, and tower is the time taken. So this is the number of bits that are transmitted within this tower time, which is BW divided by 2, BW into tower by 2, because tower by 2 is present here, as you know. So tower by 2, and then log2 of 1 plus SNR. Now, this SNR is basically minimum of gamma PT and gamma PTPR plus APPR. Now, why is that? Because this is basically, if you look at the picture again, so there are two phases. Okay, so first phase PT to IoT AP, and the second phase is, so this is the first link. You can imagine that PT to IoT AP. This is the first link, and the second link is PT to PR and IoT AP to PR. Right. So initial decoding is happening at IoT AP, and the final decoding is happening at PR. So this is, I can assume this is the first hop, and these two things are simultaneously going to the PR. So this is the second hop. So therefore, the minimum of this one and combined of these two is basically the channel capacity. Okay, so that's what is having here. So gamma PT to AP, gamma PT to AP. Okay, first one. The second one is gamma PTPR plus APPR. Gamma PT to PR and AP to PR, because these two things are coming together here, and then they are decoded. So the minimum of that is basically channel capacity, because if this link is highest capacity has a higher capacity than the other links, but still it will be limited by the first one. Okay, so therefore this is my rate, primary transmitter rate. And bandwidth of the cellular spectrum is BW. So gamma PTPR is basically given by this formula, that PT to PR and AP to PR. Okay, so this total channel thing is total gain is total SNR is combined at the receiver. Okay, so this is basically this PPT is the transmitted power, sigma square is the noise, channel noise, and this is d to the power eta 1 is basically coming because of the distance. Okay, path loss exponent is eta 1, and this is the channel gain. Okay, so this is the received SNR at the PR, primary receiver, and they are following MRC combined, maximal ratio combined. PTAP is defined by the similar formula, but here the transmitted power is PPT, and PT to AP channel gain squared is here. Sigma square is the noise, and this is the PT to AP to the power eta 1 is basically the distance to the power the channel, this exponent, path loss exponent. Okay, so so that way we can define the primary transmittance rate. Computation rate of IoT network. Okay, so this was relaying rate of primary network, and the second one is now the computation rate of IoT network. So IoT network, what it can do is it can compute it locally at the device itself, or it can partial or fully offloading at the MEC server. So either it can compute the task locally, or it can go for a partial or full offload. All the tasks it will offload to the MEC server. Okay. So this is the local computation rate. As you will see that this is this is CK is the number of CPU cycles, because there is a processor, right? So there are CPU cycles and CPU frequency. Those will come into picture. So this is a function of number of CPU cycles CK, CPU frequency FK, and this is the duration of computation. Okay, so this is the local computation rate, and this is the offloading computation rate. However, it is limited by this quantity because of the channel capacity. Okay. So this we know, this we call a constraint A, and there are offloading. So this is a function of offloading time duration. This T of K, sigma square is the channel noise, noise power, energy channel gain is HK square, distance is D, and path loss exponent is eta. Okay, so again it is limited by the channel capacity, which is given by this, and this is known as the constraint A. And there are this entire thing is a function of offloading time duration, which is T of k, energy E of k, channel gain D, distance distance D, channel gain HK, and path loss exponent deta. Okay, so this is the computation rate of IoT network. So we have seen before that the primary network wants to do throughput maximization, right? So primary wants to maximize this quantity. The secondary network, IoT network, that wants to do is basically the offloading rate. Okay, so the computation rate, and this is the local computation rate, and this is the offloading rate. Okay, and it is limited by the channel gain. Here there is no limitation because this is a computation. Okay, so channel gain does not play any role, and this is limited by the this frequency and CPU cycles. Those are the determining factors. Okay, so what are the other constraints? Other constraints, we need to guarantee certain rate to the relaying, because effective rate at the PR is guaranteed above the rate of the direct link between PT and PR. Okay, so the effective rate at PR is guaranteed to be above the direct link, because if I was using initially, I was using the link between PT and PR, right? So now what we are doing is we are using the access point also, right? So ultimately, after using access point, my rate should be bigger than the previous scenario. Then only I'm benefited, right? Otherwise, my cellular network should not allow the Wi-Fi access point to access its network. Therefore, this is a constraint that the guaranteed relaying rate after this cooperation should be more than without cooperation. Okay, and there is a frame duration constraint that local and remote computation should be completed within the frame duration. Otherwise, it will lead to certain deadline violation. Okay, because the task need to be completed within a certain time, right? So if you are like local, whatever it is, either it is local or remote computation. By remote computation, I mean the computation at the MEC server. So if it is does not completed within the frame duration, then there is a problem. Okay, so these two constraint also has to be allocated. And third is energy limitation at the IoT node, because IoT node is also coupled with very limited amount of energy. And there is a maximum CPU frequency at the MEC also, because MEC server also there is a device which is computing, and there is certain CPU frequency that the MEC server might have. Okay, so now my problem statement is defined. So I want to maximize the relaying rate in the primary network, maximize the computation rate in the IoT network, and there are certain constraints associated with it. First constraint is my offloading rate is upper bounded by some number, and the guaranteed relaying rate after the cooperation is has to be greater than the without cooperation case. There is a frame duration constraint because the task computation should be done within the frame duration. Energy limitation at the IoT node, and there is a maximum CPU frequency at the MEC. Okay, so this will define the problem. Okay, so anyone has any doubts, otherwise please feel free to post in chat, and we can have an interaction after the talk also. I'll take a small pause here and then move on to the next slide. So basically, we are now defining our problem. The problem is well defined now, that there are certain maximized objective for both maximization objective for both primary and the secondary network, and there are associated constraints. Okay, so let's move on to the next slide. So this is my safety optimization. The primary network wants to maximize the relaying rate, and the IoT network maximize the computation rate. Okay, so this is my problem. I want to maximize this quantity alpha R relay. So R relay was here. Yeah, this is the primary objective function, and this is the secondary objective function, right? So what I am doing is I'm saying that this is my alpha R relay, and the secondary objective function is RK plus MECK for all the devices. RK is the local computation time, and MECK is the offloading time. Okay, so I'm giving weightage on alpha as well as 1/1 minus alpha weightage on the IoT network and alpha weightage on the primary cellular network. Okay, so depending on the level of cooperation, you can tune this alpha also. Okay, so my primary objective function is basically now combined objective for both the primary as well as the secondary network. R relay is basically the rate obtained after relaying, and this entire second term is basically for the so this second term is basically that is for the secondary network, and this is for the primary network. And alpha and 1 minus alpha, these are the weightages. Okay, so alpha is basically somewhere between 0 and 1. so so now we have constraint A, B, C, D, E that we have seen before. I will not go over the constraints again. So this is my problem. Okay, so as it turns out that this problem is a non-convex optimization problem. So this becomes very difficult. So when we encounter some non-convex optimization problem, then solving the problem becomes very difficult. Therefore, what we want to do is we want to see if that problem can be converted into a convex one by some technique. Okay, so there are certain optimization properties that help me in doing that. First of all, the constraint C and E that hold at equality. So constraint C was this frame duration and maximum CPU frequency. These two constraints hold at equality, and optimal CPU frequency allocation to IoT K is proportional to R MEC K. So the CPU frequency that I am allocating to IoT K is proportional to the rate from the kth device to the MEC server. So using these two facts, what I can do, and I am putting an additional assumption that all IoT nodes tasks are identical. So basically CK and is equal to C. So all nodes tasks are identical, and these two results are holding, constraints are holding at equality, and optimal CPU frequency allocation is proportional to our MECK. By clubbing these two things together, we can have a convex optimization problem. So therefore, the non-convex optimization problem that we were seeing in the last slide now can be made a convex optimization problem by using these two facts. The first one is this constraints C and E that holds at equality. That means that the constraint we get the equality. So this it is a less than equal to or greater than equal to constraint, but optimally you can sort of reach the equality. And the CPU frequency allocation is proportional to the rate from the MEC to the IoT, which makes sense intuitively. And there is an additional assumption that all IoT nodes tasks are identical, which is a very reasonable assumption. So by using these two facts together, we get a convex optimization problem. So this is the modified problem. Okay, so as you see that this objective function is basically same as the previous, and there are subject to constraints ABCD, and this is the new constraint that is coming into picture. Okay, so constraint E, there was constraint E that is modified to be like this. So this is nothing but the after this, if you just apply this optimal CPU frequency allocation is proportional to this, you get this. Okay. These are the constraints, and then we can get the optimal solution by solving the following dual problem, as the duality gap is 0. So this is the primal problem, and since it is a convex problem now, you can ideally solve the dual problem also. So dual problem is basically when you use the Lagrange multiplier and write the Lagrangian and then solve it over the dual domain. And since the duality gap is 0, you can get an optimal solution. Okay. Now the dual problem can also be divided into two sub problems. And finally, so this is my P2. I have converted my problem P1 into a problem P2. Okay, and finally, optimal solution for P2 is basically these three things. Okay, so evaluate parameters using KKT condition, because since we have developed a convex optimization problem, therefore the KKT conditions will come into picture. So you evaluate the parameters based on the KKT conditions. You calculate the Lagrange multiplier using subgradient and ellipsoidal method, and these two things basically we repeat until convergence. Okay, so we evaluate the KKT and then calculate the Lagrange multiplier using some method, and then until and unless this Lagrange multiplier converges to the optimal Lagrange multiplier, you keep on doing it, and after that you obtain the optimal parameter by solving a linear programming. So finally there is a linear programming formulation. You solve the linear programming and obtain the optimal parameter. That will give you basically, since we are optimizing over all these quantities after these operations, all this optimal value of all these quantities we will be able to see. Just to repeat, we had a non-convex optimization problem, and then we applied these results as along with the additional assumption to get a convex optimization problem, and then we get this modified problem, which can be solved by the dual problem, and which we can solve the dual problem because the duality gap is 0 since it's a convex optimization problem. And then you do this. First, you evaluate the KKT condition because, as you know, for the convex optimization problem, KKT condition can be applied, and they calculate the Lagrange multiplier using some methods and obtain the final solution by linear. Okay, so this is the result. As you can see, if you do equal processor allocation to all the IoT devices, then this is the total utility. Okay, and if you, because here you see this result basically helps me. The optimal CPU frequency allocation is proportional to this. So if you don't do this, if you just do optimal allocation, you just do equal processor allocation, then the total utility becomes this. And there is, if you do the optimal one like this, what we have discussed in the last slide, and then you get this quantity. So total utility, as you see with the function of alpha is varied from 0.1 to 0.9. The total utility is becoming more. Okay, so now can you guess why as a function of alpha the utility gain is reducing with the value of alpha? Can you guess? In the chat you can post your answer. The question is why you see that when alpha value is low, then the utility gain of the optimal compared to the equal processor is very high. But as alpha becomes close to 1, the utility gain sort of falls. Why is that? Alpha was defined here. You want to know? This is the value of alpha. So alpha and 1 minus alpha. So why with increasing alpha, you basically get a lower gain? Please post your answer in the chat. If you have any doubt, you can raise your hand also. Yeah, I don't see any answer in the chat. Okay, so the reason, I'll just tell the answer because there is no answer in the chat. And the reason behind this is basically when you make the alpha close to 1, then you are putting a lot of weightage on the primary user service and less weightage on the secondary. Therefore, your utility gain is basically becoming lesser. Okay, so because all of your you are not basically facilitating the cooperation. Okay, so when alpha is somewhere close to 0.5, you are giving equal weightage to both the networks. When alpha becomes close to 0.9, close to 1, that means you are sort of giving a very limited amount of gain to the IoT network. Therefore, the utility gain is less. Okay. So there are other results also related to the fact that both the network gain from each other. That results I have not shown here. You can search it in the overall on the whole paper that I will describe at the end. Okay, so to conclude is both primary and IoT networks get benefited from the cooperation, and we proposed a joint optimization method, okay, that outperforms the equal processor allocation at the image server. And the future work in this direction is the distributed design. Okay, so we see that both the primary and the IoT network get benefited from the cooperation. The primary network gets more rate than it used to get when there is no cooperation between IoT and the primary network. The IoT network is allowed to use the cellular frequency band, the license spectrum. Therefore, the IoT network also get a lot of throughput, a lot of computation. Computationally, it becomes very good for him for the IoT nodes, because it is basically allowed to use the TDMA structure, which was unavailable in the Wi-Fi setting. And we proposed a joint optimization method that outperforms the equal processor allocation at the MEC server and the distributed. So this is a decentralized approach, because the spectrum allocation is happening at a centralized space. If you want to do a distributed design of such a network, that remains as a future work. And so there are other directions as well. For example, nowadays machine learning is picking up, and since you want to achieve some automation, basically machine learning is a very good quantity, because the kind of algorithm that we have discussed in this talk, basically it requires computation at every time or some fixed amount of allocation. But when the network parameters changes, or for example, when the value of alpha changes, right? Because it may happen that today I am allowing them some weightage based on the value of alpha, allowing the network some weightage. But in future, it might happen that I am not being allowed, I am not using the same weightage. Basically, it becomes a problematic thing, because you have to redo the optimization problem again, resolve it, and then get a solution. So therefore, some sort of machine learning based idea might be useful, which adapt the solution based on the value of alpha in automatically. Okay. So, so yeah, machine learning is typically one of the most criteria, and another criteria is one of the this kind of formulation that we have shown in these slides. They do not take into account the factor that there are arrival and departure of users. Okay, so we have seen that they consider that all the IoT, there are k IoT nodes. Okay, but in real life it may happen that there are arrival and departure of users, so the number of IoT nodes may not be fixed. So in that case, the machine learning will be a good thing, because it will basically take into account the arrival rate and the departure rate, and based on that, it will optimize. Even if there is a change in the arrival rate, it will automatically adapt. Okay, so this kind of applications, when the IoT number of IoT devices is k, it changes from k to k plus 1, you have to redo the optimization again. Or when the number of devices increase or decrease, or when the value of alpha changes, so you have to redo the parameters. And here the one of the most one of the most strongest assumption is the users are stationary. That also may not happen in some cases, as we have seen. So for example, there is this sharing bicycle application, right? So there are bicycles which there are sensors, and when the bicycle is free, it will advertise its availability to the users, and then the user can occupy. So these kind of applications also, the users are mobile. Okay, so it may happen that the sensors are mobile. So there are many future directions that can be taken up, and the work that we have seen today is one of the interesting ideas in that direction, that cooperative relaying, where you use the relay, and therefore by using the IoT API as a relay, the cellular network gets benefited, and by allowing the IoT network to use the cellular network, the IoT network also basically helps in getting a centralized TDMA behavior, and then thereby increasing its throughput. Okay, so these are some of the areas that can be taken up in the future, and these are some of the references. Today we talked about this paper, which appeared in PIMRC last year. And this is one of the good conferences in the communication community, and some more references are here. These 3GPP documents are also very useful. Okay, 3GPP TSDSI. These are TSDSI is basically the Telecom Standard Development Society of India. They also have some IoT based study, which are available online, and also 3GBP, which is standardized community worldwide. And basically this documents will be very useful if you want to dive deeper into IoT and smart home. And I think that's it from my side. If you have any questions or doubt, you can unmute yourself and interact directly. Thank you.
Thank you, sir. Thank you for this wonderful lecture. So, dear participants, in case if you have any queries, you can raise your hands. We will unmute you and you can interact with the expert directly. So dear participants, in case if you have any queries, you can also let us know in the Q&A section and chat section, or else if you want to ask the queries directly to the expert, you can raise your hands, we will unmute you. So dear sir, I guess there is no queries from the participant side.
Okay. Okay, so
Yeah.
thank you for the kind invitation. Thanks a lot for for attending this talk. Okay, thank you. Bye.
Thank you, sir. Thank you, Dr. Argyadip Roy, sir. On behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya, sir, I thank you, sir, for coming on board and sharing your knowledge with us today. So I guess we have another one lecture of yours on Wednesday, sir, on morning.
Yes, Wednesday 10 a.m. Right?
Yes, sir, 10 a.m.
Okay.
So, sir, we will meet you again then. Sir,
Okay.
thank you for joining. Thank you for joining. So I request you to disconnect, sir.
Okay. Thank you.
Thank you.
Bye.
Thank you. Thank you. So, thank you so much. So dear participants, we will now shortly begin with the lecture number 8 with our next expert, Dr. Debanga Raj Niyog, sir. So we will have a short 4 minutes break. So within that, I want to make one announcement. We have updated the attendance sheet of day 5. So we request you all to please check your attendance as per the serial number. In case any queries, please let us know. Also, we request all the participants to please check the spelling of your name in the attendance sheet and also the spelling name of your institute details so that we can make all the correction before the issue of the certificates. So we will have a 3 minutes break. Thank you. Yeah, Debanga sir, are you there?
Yes. Can you hear me?
Yes, sir. Yeah, we can hear you, sir. Welcome, sir. So we are giving you the presenter, right, sir?
Okay.
Yes, sir. We have provided you the presenter rights. We request you to share the screen before the lecture begins.
Okay, sure. Is it visible?
Yes, sir, it is absolutely visible, sir. So we will start by after another 2 minutes. By 11 o'clock,
Okay.
sharp, we will start the sessions.
Okay, sounds good.
Thank you, sir. Hello, am I audible, sir?
Yes.
Okay, thank you, sir. So before we start with the next session, we will have a short introduction about our next speaker. So our next speaker is Dr. Debanga Raj Niyog, sir. So Dr. Debanga Raj Niyog received his PhD in
Hello. I cannot hear you actually. Hello.
solutions to solve problems in industrial inspections, supported by global accelerators such as Techstars. Dr. Niyog joined IIT Guwahati as an assistant professor in Mehta Family Schools of Data Science and Artificial Intelligence in September 2021. So with this, we welcome you, sir, for the next lecture on wearables and IoT. Over to you, sir.
Thank you. Okay, so I'll start my talk now. So this topic is wearable and IoT. So this topic is kind of pretty multifaceted because wearable IoT and the algorithm behind these technologies, they are very big topics. So I'm sure in last couple of lectures in this FDP, you have learned a lot about different aspects of IoT. You have also seen maybe different kinds of things, right? Internet of Things we talk about. They're just different kind of things, how they're connected. And you also know that one of particular class of those kind of things are the wearables. So my background is in machine learning and computer vision. So this talk will be more from the perspective of these two topics rather than going for core IoT technologies in the sense of communication security. But I will just give you an idea in general how these wearables, IoT, and the algorithms, the brain behind it, they work together, and some different aspects. There's pros and cons, the challenges. So I'll try to cover all of these things. So I'll just give you very simple definitions in the beginning so that some of you, if you haven't, if one just a refresher of the IoT about IoT, I'll just give you a very basic definition so that it helps me to connect it to the wearable technologies that I'm going to talk about. So if you just go to Wikipedia and search for Internet of Things, this definition you will get, right? So the Internet of Things describes physical objects, okay, or a group of such objects that are embedded with sensors. So this is very important that we have some objects and they are equipped, they're embedded with sensors. They also have processing ability. That means you will require a processor. You have a software. This software is the brain behind it. And the other technologies that connect and exchange data. So connecting is very important because all these things that we're talking about, they should be connected. And there will be some communication where these things will be, communicating different data in bidirectional way, right? So, for example, say you have a fridge and you have a phone and then some other devices, they're all connected in the smart home, right? So they're sending data to each other. So maybe you have sent a signal to the fridge, or maybe the fridge is telling you through some signal that, there's some kind of problem is there. So there need to be exchange of data with other devices and systems over the internet. So you also need to be accessible to the internet or some other communication networks, right? So that you are visible to the internet, you're visible to your network, so that they can talk to each other, right? So this is what, for example, in the Wikipedia, it tells you. And all these things like physical objects, group of objects, embedded with sensors, software processing, connecting the data, exchanging data, all these things are very important. And there are a lot of different algorithms working behind it. So it's a very complex topic. But there are some key features, right? So for example, in the definition that I mentioned in the beginning, so we talked about the sensors. So sensors are very important because that's how these devices see, right? How we see as a human being with our eyes, these devices see through sensors. So these sensor devices used in IoT technologies detect and measure any changes in the environment, right? So just like how we sense the environment, they also sense the environment, depending on what kind of the thing it is and what kind of application it has to do. And then they will collect the data through the sensors, and then they can report, right? So in our normal world, when we have a lot of different, electronics objects lying there, for example, you have a toaster, you have a fridge, you have a TV, you have a phone, you have, a computer, so many things, but they are very passive network, like they are not connected, right? They cannot talk to each other, but this IoT allows them to talk. And to talk to them, they should have a sense of the surrounding, which is very helpful, and that's why the sensors are there. Then we talked about connectivity. So connectivity refers to establishing a proper connection between all the things. That's what also we mentioned. But this connectivity could be to a local server, could be a cloud. But one important thing is that when we talk about this connectivity and IoT, we are basically exposing ourselves to some extent, right? Because now someone, if you have a fridge inside your home, unless someone physically, comes to your home, they cannot access the fridge. But now, since you are connected to some kind of network, someone might be able to connect to it and do some kind of, say, unintended thing like hacking. Right? So it has to be reliable, secure, and also there should be a bidirectional communication. And then comes the brain part, intelligence, right? So IoT using AI can make the virtually anything smart. So you need some algorithm behind it who can smartly do things. It can basically collect the information from sensors and do some smart decision making, right? And then finally, user engagement is also very important because all this kind of objects that you have, they have an interface where people, talk to them, people kind of interact with them. So, and these days, because there's so many objects are there, electronic objects around us, starting from your car, starting from your all these home appliances, you need some kind of interface so that you can communicate to them and give some instruction commands, right? So these are the key features that you might have already seen in the previous talks. And in our world, we have all these things. They have different sensors that can sense temperature, pressure, position, weight, speed, flow, and whatnot. All this kind of sensors can sense all these features, right? And then we are then basically these are in the real world, and then sensor is assessing them through some kind of electronic circuit, okay, some kind of system. It is equipped with that. And there's also some kind of there is also this intelligence part, right? So it could be here also, it could be in the network also. So, but at least we know that these sensors are going to collect some data which is relevant for us for some particular application, and they are sent to the network. And if it's close distance, some of the things that we have, they need to work in a smaller kind of range. So we have a lot of different low-powered communication protocols, and are there. And then finally, we also need to interact with cloud. Mostly, you see these days, a lot of these devices that we have, they also interact with clouds. For example, maybe Alexa. It may not be locally processing something, maybe sending something to cloud to some AI model and getting the result from there, and then they're using that information to do the task, right? So these things that we have, they are assigned an IP address because it has to be visible. Then these objects have the capacity to collect and transfer data over the network, and these objects interact with the external environment with the help of embedded technology, which helps them to take decisions. So you have sensors and some intelligence behind it, right? So this kind of connections could be man to machine, machine to machine, anything to everything. So this is what IoT will. Now when you talk about is this different kind of sensors, depending on what kind of application it is, we use a subset of them, right? So there are a lot of different applications IoT can have, starting from, smart city, smart health, smart agriculture, that I think you will also gonna see in one of the coming lectures, I think. Then smart wearables that we're gonna touch upon a bit, and then smart retail. So all these things, these are different applications, but we'll be focusing on wearables. So why the IoT is important? Because it's growing. So if you see the number of connected devices with respect to number of population, it is growing. So maybe now we have, when you talk about IoT, that means we're talking about multiple devices. So every household will have multiple devices that are connected. So that means it will definitely, cross the number of people in the earth at some point of time. And that happened in 2008, for example. Here it's saying the number of things we talked about connected to the internet exceeded the number of people on earth. So this is a growing field, and this is what we are heading to, having a connected world, and that world will be supported by IoT. Okay. Now, since we have a lot of devices, they're collecting a lot of data. Now, if it's a small amount of data, it is fine. You can store in your phone. If small amount of data, we can maybe on hard drive. But since it's a connected world, a lot of decision makings are collective. For example, what a particular my device is doing, it depends on what all the other devices in the world is doing, right? Because it's learning some kind of collective behavior, right? What is the best way to act? It will depend on how other people are behaving or how other devices are behaving. So there are a lot of data you have to collect in this process. And again, everyone who is using, for example, Alexa, they're collecting, these devices are collecting data and they're storing it. They're giving it to some AI model so that they can improve the experience of the users. So we're collecting a lot of data, and where these data are going, mostly some kind of data station, like Amazon, like Google Cloud. All these are places in the cloud where people store data, right? So they are collecting this huge amount of data so that they can use them to improve the experience of people. Okay, it also comes with some issues like whether they are secure, what if something happens in the data center, some crash happened, are they safe? So these things, these cloud service providers are doing it. If you go for Amazon, if you go for Google Cloud, they if you go to the documentation, they'll say they'll make sure that all of these things will not happen. But again, you can trust any kind of corporates to some extent only, right? But that's what we are now. We have to trust them. So, and there are a lot of alternatives also. There's some competitions. But the main point is that cloud is very important in this framework. Then once we have the data in cloud, so it's a lot of data out there. So big data comes into picture. Then of course, machine learning and deep learning are coming to picture. Machine learning, because a lot of, for example, some kind of smaller predictions, simpler predictions you can do with simple shallow machine learning algorithms. But these days, if you're dealing with like images, videos, then you have to also look at deep learning algorithms, because they are giving the state-of-the-art results these days, right? And if in this picture, basically you're saying that maybe you have a vending machine is sending some data to the cloud. And some aggregation happening from maybe even in this stage with some different sensors. And then once we go to the cloud, maybe the cloud for the AWS or Google Cloud is hosting some kind of machine learning kind of API that will do all these tasks, like, like loading the data, extracting features, then developing model, testing the model, and then, find out the model with the most, with the best performance. And then once you have the model, they can use it for some practical applications, maybe when to call the supplier so that they can fill this vending machine up. So those kind of things can be automatically done. And as you can see, less and less manual intervention is required these days, because we have these smart algorithms behind it. And this is just briefly showing you the computation layers. You have already seen them. So you have all these layers of different devices. Your smart, smart home, smart city, personal health, and you have different kind of layers that maybe in the beginning through low power wireless connections you are sending to your mobile phone, for example, from your wearables. And then there's some other computation will happen in layer wise in the cloud. And then this kind of communication could be bidirectional. So these things are happening. And then mostly we'll see that Bluetooth or Wi-Fi, these are used typically in our home, the things that we have in our home. And wearables in particular, you'll see that is predominantly we use a lot of Bluetooth, for example. And the frameworks Then I think in some of the hands-ons in this FDP, you'll try it out. So personally I'm not an expert, but I have in some of my projects when I was working in corporate, some of my teams were working some tools like AWS IoT Core. In particular, in my project, what it was that we are there's a fleet of robots, and then we are collecting the data from them and then sending to securely to a web server, and then taking decisions based, and then decision was sent back. Some of the decisions were sent back to the robots, and somewhere actually could be visualized using a dashboard. And there are a lot of other open source tools out there, so you can try out. And some of the features that you have to always look at while you're trying those frameworks, which most of them anyway they'll take care of, but to what extent you have to figure it out. Scalability, security, and fault tolerant, and how customizable the user interface is, because these things will be important when you're actually delivering a product to a customer, for example, because they look for all these different features. Coming to the wearables, so all of you must have have access to some of them. Maybe you have a smartwatch, or maybe you have a smart headphone, AirPod, right? So these are the smart devices you can wear in your body. So this could be so many times when you talk about wearables, you only think about maybe it's your smartphone. I mean your smart watch, or maybe you are wearing some kind of smart glasses, which are very costly, but many of you might have access to them. So those are external accessories that you can use, and there are some who actually can be embedded into clothings and the garments. They can be even implanted in your body. I still recall one of my friend when I was in Canada, he was actually implanted some chip in his body and was giving some information about it was, I think, RFID kind of tool thing, that he was able to unlock the door and then do some other activities. So it was actually in his body, and he was wearing it physically. And also there are some tattoos and all those things that you can do these days that can be called wearables, because they are smart in a way that they can connect to other things. We are used to a traditional things. I mean, traditional objects like watch, eyeglasses, hearing aid, activity tracker, and all those things. And now we have a smarter version of them, right? And we wear them. Although there are a lot of different people have different concerns, like for example, in terms of how safe they are in terms of all these radiations they're sending, or in terms of how much of connectivity you are exposing yourself to the world. So those things you have to think about. But anyway, so they have become part of our life, right? So examples that I already mentioned, some again I'm listing them: smartwatches, wristbands, like Fitbits. Many of you wear when you are doing exercise. You have eyewears, eyeglasses like Google glasses, headsets, earbuds, body straps, and so on. So these are devices. At some point of time, it was kind of luxury, but now you can just go to Flipkart, Amazon, and buy them. So this is what we are right now. When you talk about the wearables, these are pretty kind of similar how the other IoT sensors work. But one thing is that the sensors that we use in those devices, they are placed very close to our body, right? So because anyway, they're wearing them, so they are kind of becoming part of us when you wear them. The sensors can monitor, of course, the temperature, movement of our pulse, that can be used for, for example, tracking, find out, maybe if your heartbeats, what is your heartbeat? For example, you're doing exercise, you might want to track that whether my heartbeats are, increasing or not, and whether it's below a certain level, whether my cardio exercise is being effective or not. So all these things you can do. In the second layer, of course, you have connectivity and control. So your wearable devices has to be connected, maybe your smartphone. A lot of these wearable devices comes with an app that can be installed in your phone. And that gives you a lot of kind of benefit, in the sense that something that smart in your wearable, it might not be possible to have an interface, for example, UI in there. But using your mobile phone, you can connect to it and do a lot of different activities, different kind of setting changes very easily. and or the device can send the data, some data that to your phone if they are connected, maybe so through Bluetooth. And then once it is in your phone, then it can send to, for example, the cloud, the third layer. So you can supply the data, maybe do some kind of AI computation out there, and then get the results back. Right? So that will be very useful. And of course, that is possible that these wearables are coming. They also have some kind of could have internal processors, depending on like what kind of device it is. For example, maybe Apple Watch, for example, it might have a kind of a processor that is powerful, and they can do a lot of computations locally in the device. They don't have to send to the cloud, but sometimes there's some kind of inferences may have to do using AI. In that case, you have to send the data to the cloud. Okay. In the wearable, some of the sensors that I want to mention, there are some biopotential sensors, for example, EEG, ECG, EMG, EPG. So these are pretty useful. For example, if you are wearing a kind of a wearable which is related to your health, related to healthcare. Then you have motion sensors like accelerometer, gyroscope. So these are useful. For example, you're wearing a Fitbit, right? So you're running and you want to track of how far you have run, and what is your heartbeat right now. All those things you can collect. Environment sensors, ultrasound, pressure, temperature, etc. Then you have biochemical sensors. Then you have vision sensors. So the vision sensors are something that I'm mostly have worked on, whether it's a color camera. So there could be IR cameras also, infrared cameras. There could be depth cameras. For example, I know I have worked with a lot of AR and VR systems, glasses where, these days they have one of them or all of these vision sensors. For example, imagine that if you have there's a firefighter, right? So, and he's wearing a kind of a goggles that is equipped with IR cameras. So how helpful it will be if he goes to rescue someone, because there may be darker room, there's been no electricity, and so you have to see in the dark. So this IR camera can help, right? When there's no light. So, and this kind of cameras are giving a kind of superhuman capability if you wear this kind of wearables, right? So adoption and development is accelerating, of course, is because advancement in low power mobile networks, and then decrease in size of the electronic devices and sensors. So as you see over time, then even if we don't talk about wearables, if we talk about, for example, your smartphones. Now think about it, like how many cameras these days you have in a kind of smartphone that in the range of say 20,000 or 15,000 Indian rupees. So you'll have there are 4 cameras maybe, right? Or 3 cameras. So why do you have a lot of cameras? Because they have more sensors, they can collect more data, and they can do some, with that amount of data, since we have developed many AI, you can do a lot of computations. For example, say HDR, right? Your phone must have HDR, which is high dynamic range computations. For example, you are in a very bright sunlight, and then there's a shadow behind a tree. So if you try to capture that scene, then you'll see that you will either see the bright region clearly, but then you'll not be able to see the darker one. But if you see the darker one, then you'll not be able to bright, because the sensor doesn't have that kind of dynamic range. But then what happens, then you can actually collect different snapshots from different cameras and also at different time, and you combine the data, and then you can pick the most kind of relevant areas and then combine them, and then you can tone map back to a simple image. In that case, you will see that you will be able to see all the regions pretty clearly. And these things can also be in your wearables. For example, you're using air glasses, right? So in air glasses, maybe you are using it for while you're driving, right? It may be giving you some information about your space around you, like your pedestrians, your street. In that case, if there's sunlight, what happens? Your sensors that is collecting information by looking at the surrounding, it may not be able to collect it, right? Because there'll be a lot of bright pixels. In that case, maybe using this kind of technology like HDR, and essentially there could be an AI algorithm behind it. You can improve the algorithms, the capability of the sensors, and in general of the device. So advantages, if you talk about, there could be, of course, there are a lot of advantages, and that's why people are also going for it. Increased productivity, enhanced speed, superior task accuracy, because now you're kind of getting an additional sensor with you, right? And plus not only sensors, there's a smart brain working behind you. So for example, you're using air glasses, you're using a smartwatch, or maybe you're using a Fitbit. So you're collecting all this information, which manually is not possible. You have to go If you think about the past, you have to go to a kind of very complex sensors system where you can collect the data. But now everything you can do, can wear it, and that's the beauty of it. So if you think about, like, for example, Apple Watch, you know, these are pretty advanced these days. Like, you know, you can see that you have a battery not as powerful as a smartphone, but is enough for the application it is that we have bought it for, right? And you can see that it has network connectivity, and you know, you have enough memory, 32 gigs of. I mean, this is the start slot, but if you think about, you know, memory or processors, you know, or all these other kind of sensors they have equipped, you know, speakers, battery life. You can see that if you compare with some other devices a long time back, these are pretty commendably good. And sensors, you have accelerometers, gyro, heart rate barometer, and all this. So it is a pretty, you can think of it like as a computer, right? So you can talk about Google Glass. It's a wearable, so it also has inbuilt processor. You know, it has a battery that can last pretty long. I mean, depending on how much you're using it. It has Bluetooth, Wi-Fi, and all these connectivities, right? So then you are then these devices has also, you know, some pros and cons that I'll discuss. Like, you know, although we are going with a lot of wearables, but some wearables are kind of getting more traction while some others are not, right? Now I'll just briefly want to talk about the AI part, because that's what the brain of this wearables are, right? So for example, if you haven't seen this, so this particular diagram you'll see everywhere, right? You know, so it talks about what is AI and what is machine learning. So some people might say these are the same, but to understand what are the relationship between AI, machine learning, ANN, or deep learning, this figure is enough, right? So you can see that AI is a broader kind of set where you have rule-based algorithms. There are algorithms where you can learn from data, and the machine learning is a subset of AI where actually you're learning from data, right? And inside machine learning, you have ANN. So these are special kind of algorithms where you use neural networks, which are inspired by how you're, you know, mimicking kind of a human brain. So how biological neurons kind of send signals to each other is it kind of gets inspired by that. We have created some kind of algorithms that can do it, right? And these ANNs are, as you see, the deep learning is a subset of these ANNs. So ANNs are kind of in the heart of deep learning, right? And just what this ANN actually does. So imagine that you have this space, you know, you have some features X and feature Y, and you have this different kind of data samples. Okay, this is an example. This is a black cat. This is a red cat. And this is a blue dog. This is a black dog. But in this space, if you want to separate out them, it's very difficult, right? Because I cannot draw a simple line or say that in the right side of the line there's a blue dog, in the left is a black. It's not possible. So if we just take this feature space, we will not be able to classify that if using any simple algorithm. But what neural network does, it actually takes this input space and transforms it to another space where you can actually separate them out pretty easily when we're using very simple classifiers. So this is nothing but basically doing a transformation from this space to that space, right? And once you have the space, then you can perform any kind of classification that you require. So what kind of neural nets are there? There are ANN, I have already talked about. Of course, I haven't talked about you know, what is how it works and what are different layers, but just giving an idea so that in case you are not in this area, you can go and take a look. Then there are some other kind of neural nets like convolutional neural net, which are typically used for image and video data. And there are some new architectures like transformers are coming, which use attention networks, which basically tells you not only that I'm trying to get the feature, I also want to see how these different regions of the images are also related. And this idea can be also transferred to other kind of applications where you can just think of a space where you want to try to find out how different features in the space are related. Okay. And then basically finally, if we have these ANNs, then further actually we can increase the capacity to transform the features to a more, you know, effective and kind of representative way by adding more layers. So once we add more layers, it is able to extract some more deeper features, more abstract features, and which is useful while you're performing machine learning tasks like like classification, regression, or any other advanced things like in image processing and do segmentations. So why it's happening? Because so why people are moving towards deep neural net? Because it is giving you better performance, but for that you will require a lot of data to train the model, and you also need a lot of computation power. For example, GPU-based parallel computing power can be used. Has to you have typically these are used for training a machine learning deep neural network. But as we know that this GPU based computing power is getting accessible day by day. We have a lot of data out there. So now this is a time where actually people are moving towards deep neural network, because you have all the resources required for this, and then these networks are actually giving you better performances. So as I already said, it contains a lot more hidden layers, and then a simple ANN, and then it can learn complex nonlinear relationships. And in shallow networks, also one thing you have to think about is kind of note down is that in that case we have to manually design the features of the input data. So in that case, you require some domain expert who can sit and find out, okay, this feature may be important, that feature may be important. But in deep neural net, because you have a lot of data and this very smart architecture, it actually automatically figure out from the data what kind of features are important, right? But it requires a lot of computation and a lot of data, of course. But it doesn't matter, because now we have all those resources. So now if you think about application areas, if you talk about the wearables, if you think about wearables, you have to do a lot of different tasks, right? Maybe you have to do computer vision, where actually you are wearing a glasses, there's a camera, and then you want to do some processing with the video or images. Then you need some computer vision algorithms. If you want to say you are sending some speech command, you want to using a voice command, you want to control something, then you will require some speech signal processing, right? And then biomedical signal processing is of course important, because you are collecting all this data like heartbeat, like EEG, ECG, all these kind of signals, but how to make sense of them, right? Maybe some kind of your state of your health can be determined not just by one factor. It can be multiple factors. Maybe you can combine, there's some features in the heartbeat, the features might be some EEG, ECG that can combine, and then you can infer something that is important. NLP, natural language processing, is important, because ultimately whenever you're doing some question answering kind of AI, for example, there is some AI behind it using NLP algorithms, okay? Now, computer vision, as I said, is important. For example, you're wearing an AR glasses and you're driving, then you have to locate, where is the track, what is the speed of the car currently. You can visualize on top of it, in your feed that you are seeing. Or actually, say you have if you talk about AR systems, what happens is that there are two kinds of AR systems. One is VR, one is optical see-through, where actually you are seeing through your glasses, just like normal spectacles, but there's a projector that will project on your glasses some information. Like, for example, here maybe they're projecting some speed information or some other information, for example, what is the highway number and all those things. So those things you can see. And there's one more kind of AR systems that I'm going to talk about quickly in coming slides. Is that video mixing, where actually you have a video camera looking at the scene, and then it's displaying the video through a display to your eyes. And of course, it requires some optical system, because when you're putting a display that close to your eyes, you'll not be able to focus on it, but you need an optical system, right? But in that case, you're watching the video, and then there's some information superimposed on the video. So do two kinds of things. But anyway, so once you have this kind of AR glasses, then you can it can classify a lot of things. Maybe you want to see whether there's a pedestrian crossing or not, right? So those kind of things, it can be done with computer vision algorithms, right? It can detect from the video that what are the activities happening, and then put the information on your glasses, for example. And one more important thing is, for example, now we're talking about putting a lot of those models in your device only, right? So you have some wearables. Many times it is better even if you put the algorithm itself on the devices, because it will be faster, right? Because if you see one of the in the figures that I've shown in the beginning, once you go to the cloud, there will be some latency, right? Because, for example, you are sending some image signals, even video feed to the cloud, and saying that, okay, give me some insight out of it. Then you have to send a video to the cloud. So then you have to, convert into, so basically then you have to stream the data, and that will require some, there will be some delay, because you're going through a lot of different kind of layers. And then it might not be possible to use those kind of facilities, those kind of framework, if you are doing some very time sensitive task, like real time task. In that case, you need just very fast results, right? inferences. In that case, actually, what you can do, if you can put those AI models in the device itself, it will be way faster, right? Because you don't have to send it to the cloud, get it, wait for it. But in that case, as you know, that these are low power devices, so you have to make sure that you don't put a lot of, it doesn't require a lot of power for these computations. So there's a way, for example, deep learning models, basically when you're sending data to the cloud and asking for some AI algorithm to give some insight, they're running some inference using deep learning models, for example, or say any kind of machine learning models. But if you want to put the same machine learning model to your wearable, it may not be possible, right? Because there may be huge models. They can handle it because they're in the cloud and they're running all these different GPUs and computings and in parallel there. But in device, it's not possible. Your device is a very simple processor is there, maybe small amount of RAM is there. So in that case, what you can do, there are some ways to optimize the DL models by, for example, model quantization. So you basically sacrifice some of the performance of it, but you actually can calculate much faster, right? Because you're kind of changing instead of using floating points, for example, you can quantize them and then maybe you can use integer values. So it will reduce your computation loads. So it will give you a large computation gain and higher performance. That is one thing. And second thing is quantized neural networks also increase power efficiency for two reasons, because we have a reduced memory access cost and we have increased compute efficiency. So these 2 points are very important for wearables or any kind of in general IoT devices. So this AI algorithm I'm talking about not necessarily for wearables. Any kind of IoT can use it, right? To keep in mind. So this is just a visualization of that you can convert floating point to integers. 32-bit you can convert to just 8-bit, right? So it's low power, low memory bandwidth, low storage, high performance. So these are the benefits you'll get with quantization. Speed, of course, as I already quickly mentioned before. So you need a lot of when you're sending voice commands, a lot of things actually going under the hood. Speech recognition, understanding the context. What is your state of mind? Language understanding, you translate it. Or you have to searching something online. So how actually this devices will interpret it, right? So there are a lot of steps going on in there. For example, you have to convert the speech to text, filter out the noise. This is also important. Then you have to process with neural networks, understand the context, and then do the actions required. Right? So under the hood, again, you are using some AI algorithms, some machine learning algorithms there. So just quickly, I won't have time to touch upon all the application areas, but for example, just take the healthcare, which is one of the biggest applications of wearables. So now if you ask about wearables, mostly people think about, smart watches or Fitbits that most of us, many of us actually wear them. So we know that that has a direct relation to healthcare, right? We care about our health. We want to be fit. So that's why we're wearing those. So the health wearable IoT devices is mainly used for, so that is for ourselves. And that's in healthcare sectors, you also see that those are also used for the patients, because they can keep track of them, what is the status of their health. So for example, remote patient monitoring, treatment and rehabilitation process purposes, it is used because it is a very convenient way, right? You can put the wearables in their body and then maybe through your IoT system, they can send the signals to your some kind of local server. Maybe you can visualize them. Even if you're not doing any processing, but looking at the raw data will give you a lot of insight, right? So the sensors basically collect the health-related data, and device may perform limited computation also in the device only, depending on what kind of how much computation is required. As I already said, that computation can be done in cloud, but computation can also be done in your device if it is important that you need results in real time. And maybe you can also do some computation prior to transmitting to the before actually sending it to the cloud. Maybe you require some kind of small processing. What I'm saying is, for example, as I mentioned, that if you directly stream the video to the cloud and do some processing, it will take a lot of time to then send the data and get it back. Latency will be there. There will be some delay. And what is the solution? Maybe one way is to actually locally do some processing and convert that video or image to some feature space where you don't have to send the whole video or image to the cloud, just some numbers, some features, right? So in that case, you can actually have this approach where you do some computation locally and some computation in the cloud. So that actually happens a lot in this kind of devices. And finally, when you send the data to the cloud, and ultimately you'll get some decisions and then you'll use it, right? So these wearable devices may be connected to the smartphones. Of course, we do. This is an example. if you buy an kind of smartwatch, you can also access the data in your smartphones using the corresponding app. So you can this is very useful because now in your phone you can do a lot more with the data. So you can do some kind of analysis you can see in your device, but also you can see in your phone. And also from the phone, actually, this you can send the data to the cloud for maybe some offline analysis even that you don't care how long it takes, but you just want to get the information. So you can from the phone you can send it. And of course, some of the high-end smartwatches can directly send also. But ultimately, these devices are now giving you the capacity to look at the data and understand the insights. Okay. And this is, for example, a summary where it shows that what kind of different parameters are sensed, what kind of sensors are used for healthcare IIT applications. So these are from different papers. Basically, if you go to this paper, you'll see the references. So you can see that people are using different kind of connectivities, different kind of sensors. Whether some of them has more, some of them have mobile apps, some don't, and there are some different kind of wearables they're using. Some put in the face, some put in the walker, some put in the chest, and all different kind of things they can do. So I'm just going to briefly talk about AR because this is also my research area. So quickly, and also since the AR glasses kind of falls in the category of wearables, just want to give you a quick idea because it might be interesting to know. Some of you maybe kind of want to explore more about AR glasses or even VR glasses. So if you think about it, just quickly give you an idea what is an AR, what is VR, and what is MR. So many of you may be just confusing them because they all sound same. Okay, you have a glass and you have some virtual things going on. But there's a very subtle, there's some differences out in all those terms. Just want to tell you. So there's a thing called reality, virtuality, continuum. So you can think of it as in the left side of this axis, you have the real world, and the right side, extreme right, you have the virtual world. So real world is where we live in, right? And then if you go towards the right from the left end of this axis, you see the optical see-through that I talked about. So you have an AR glass. So it's like your normal spectacles, but there's a projector, there's a projector, there's a mirror. So your glasses will act like a mirror if this is made of a special material. And then you see the surrounding and you also see some information on which was overlaid, right? Superimposed on the glasses. And so you can see both at the same time. So in the video mixing, you're actually not seeing the real world, you are seeing the video. So that means there'll be some lag, right? Because video has to be processed and shown to you, and it has to be shown to you. But in that case, your video, your information is superimposed on the video. So you're seeing that now is going slightly towards the virtual world, not real world, because now you're not seeing the real world, but seeing through a video. Then comes extreme end, you have a VR, where actually you are seeing only the digital content. You're not seeing anything in the real world. Okay, and you are not seeing the real world through a camera or something. It's completely fabricated digital world. For example, when you play a game in VR, and then you do a lot of different tasks in the world. So this is totally virtual. So you see AR and VR, what's the difference? AR, you're seeing the real world, and then you're superimposing information on it. In VR, actually, you are totally going digital, right? And in between, there are some activity. There's a category called MR, mixed reality. So mixed reality is in between AR and VR. So mixed reality, it is like AR. You're seeing the real world. You're seeing some digital content. You can put some digital content, but you can also interact with them. For example, in AR, maybe it's just superimposed, some kind of text is superimposed on what you're seeing, right? But in MR, maybe you can putting some digital character in the real world, right? And then maybe you can interact with it. Maybe say, for example, say you are an architect and you are kind of trying to build a model, then you can wear those glasses and you can visualize the models. Then using hand gesture, you can maybe rotate it, zoom it. Okay, so there's some more interaction with the digital content and the real world. So you can see the thing in the real world, but you can also interact. So this is more interesting area. So if you think about, if you must have heard about Microsoft HoloLens. So those are the mixed reality glasses where you can interact with the object. Now, if you think about Oculus Rift, so those are VR headsets. These are for gaming and you are immersed in digital world. You cannot walk around wearing them because you'll hit the wall. But using mixed reality, you will not hit a wall. In AR, of course, you'll seeing everything, you will not hit the wall, but it has some limited capacity. So for example, Google Glass is an AR glass. It's not a mixed reality glass. So this AR, MR, and VR, and together also they're called extended reality. Okay, so because there's an XR. So this is I'm showing you the information again. So in AR, yes, the digital element to the live view. by using the cameras on the smartphone or wearable devices like Snap glasses, Snapchat, and Pokemon Go is also actually AR, but it's not a wearable. This is the same AR thing, but it's in a phone, right? So this is not wearable AR. This is wearable AR. Virtual reality, as I said, is for gaming where you have a complete immersion experience, but you are actually shutting out the physical world, right? Mixed reality combines the elements of both AR and VR, but you can interact with the digital object like Microsoft HoloLens. So, for example, this is an eyeglasses, AR eyeglasses, where you can see they also have sensors, and why? And because of it satisfies all the criteria that and thing should have, like, you know, it has sensors, it's connected to the internet, it has a processing unit, it has a display and projections based on what kind of AR system it is, whether it's optical see-through or a video mixing AR, reflections depending on again what kind of glasses it is, and then in behind you have AI algorithms, right? These AI algorithms are kind of the brain for these eyeglasses. So now these AR glasses I just want to show which are wearables, can be used for different kind of IoT scenarios. For example, Industry 4.0, right? So which is also known as IIoT, Industrial IoT, right? So here you can see that a lot of activities going on in this factory field. You know, some people are maybe kind of actually visualizing, you know, the data coming from. Some are actually doing the work. Some packaging. Someone may be scanning the kind of the packages. Someone may be selling the objects in the kind of in a shop. So they're not necessarily in the same location. They could be in different location. That's what the power of IoT, right? But they're all connected. Whether it's a production line, design, innovation, engineering, delivery, tracking, and they all can be connected. So why I want to mention about this AR glasses and wearables here. So I'll see where we can place it. So this is IoT. You can see there's all these different components, right? So you have big data and AI and you know, cloud computing, autonomous robots, cybersecurity, because all these things are important. There's one more component here. It says that AR. So how this AR is coming into picture. So this is one of the projects that I did before. So that's why I wanted to kind of talk about it. It is about how we can build a wearable that can help the people working in the in manufacturing, for example. So one of the activities that you know it happens is the welding, right? So we actually you create this bright arc, kind of very kind of hot arc, and that actually can join the metals by melting them and adding some material, and then material actually can kind of works like a glue. You know, when it's molten, it fits to it, material where you're working on, and then it glues it, right? So welding is basically where you kind of join, for example, two metals together. So where is AR coming here? So before that even, we know that, as I said, that it's very useful task because it has been used in a lot of different industries. It is an important part of manufacturing. Whether even it's construction, for example, you're building a house, you'll see that you'll always see someone welding there, right? Some bright arcs. And whether it's a building, even if you're building an airplane, you're building a rocket, missile, robots, doesn't matter. Always welding will be there. So it is a safety concern because there are a lot of health hazards there, especially for example eyes. These are because they're exposed to these bright lights. Sometimes maybe your this screen helmet is not working, or sometimes you are just somehow by mistake started the arc, and then it kind of caused this this damage to your eyes because there are a lot of harmful rays coming out of this, and also of course the bright kind of arcs coming out of it. And also we saw from our research that actually the welders are performing not that well. So we are losing a lot of money because maybe they are making a lot of mistakes. And sometimes what happens is that many times what happens is you are not able to actually when you are actually doing something wrong in welding, what happens is that you are not able to again weld it together. So you have to throw those as scraps. So that also happens many times, right? So, and finally, because people think it is a very, you know, dark, dirty work, and then they are not coming to this. Can we actually make it more attractive and through some kind of new technologies, right? And this is a real thing also. I found that I have personally met a lot of welders, and what happens is that when Sometimes they work the whole day, 8 hours, even more, and then when you go home at night, they cannot sleep because your eyes are burning. Although they are not damaged, but they feel it. Like, it's such a very difficult job. So we're thinking, how can you solve it in a way? Can we use some wearables so that they can assist, they can be assisted, and those kind of stats that we're seeing here that can be improved, right? So now what happened is that we have actually used this build this AR headset, which is video mixing. And what happens is that if you use a video mixing AR, of course, I'm telling you, you are having a camera, and then through camera you're seeing it, right? But if you use normal cameras, you'll see like this. But we use some HDR technology using AI that will actually improve it, so that through the AR glass you can see very clearly. So even if you're wearing those kind of glasses, you'll see this point clearly, but you'll not be able to see because this is just like dark shade. But using this technologies, actually you can not only see the point where you're welding, you can also see the surrounding. Okay, so this involves a lot of segmentation and tracking algorithms on the video. And this is, for example, one of the results that we got. Like when you're welding, you can superimpose all this information. What is the speed? What is the angle? How far the weld is? All these things are important if you want to improve the quality, you want to reduce the number of waste and all this information. So finally, once all the welders are wearing these headsets, they can be sent to some control center where someone is monitoring and finding out, okay, this thing is not going well. Then they can actually connect back and send some signals to them. Okay, maybe stop welding, or something is going wrong. So this kind of helmets can be used as a thing, and then can be connected through a network, and then people can actually figure out if something is going wrong. And this thing can also be useful if you want to train some new welders, because now in the beginning they might not know like how fast you have to go, or maybe they are not able to track how fast your hands are moving. But using this kind of devices, you can find out superimposed like AR glasses, right? So then there are a lot of other areas where wearables are used, and then they can be used as a part of IoT network. These are, for example, defense, it's very important. Activity recognition, sports, health, we already seen. Tracking and localization also, you have these wearables. For safety purpose also, you can use this. So I'll not go through all these different applications, but I just want to give an idea. So the challenges I want to quickly discuss about it. For example, Google Glass, this kind of wearables. So we have already talked about AR glasses. So what are the concerns? When it came, it was there's a very big hype, right? Okay, this is the future. This is what the future look like. Everyone will be wearing those glasses. But we'll see it's not the case right now, right? What happened? So there are a lot of concerns out there. So people still care about privacy, care about social acceptance. If you're wearing the glasses, you're keeping your camera on, some people might not be comfortable when you go for example, coffee shop, right? So comfort, usabilities are also the cases where actually you have to make sure that those devices are not heavy, and then you don't feel like charging them every time, So those are the things that are there. So this kind of AR glasses, in consumer level, yes, there may not be that successful yet, but in many kind of applications like manufacturing and or some other areas, people are actually starting to use it. For example, medical surgery also, people have started using AR glasses that will really help them to do. So maybe you have to find out the right domain where it's useful. It's not just the consumer using it just for an entertainment purpose, because this is kind of, we have to make sure that all these different kind of concerns are also solved. Power consumption is a kind of a problem sometimes. For example, what if you have to keep charging them, right? That is not very convenient. You're wearing those glasses, for example, or any kind of IoT devices, your smartwatch. So then if you keep charging them, you have to keep charging them. It's not very nice experience. So in particular, if you talk about these kind of glasses, many times what happens, they have a lot of, they need to do a lot of computations, because your wearables, your smartwatches, you may not have to, there's no kind of video sensors, right? But these glasses also have video sensor that consumes a lot of power when you're keeping your camera on. So some solutions are people actually use some wired devices, like in a wired kind of a charger or some kind of computing system connected to the eyeglasses. Again, it's not very convenient. You have to carry both of them together. But if it's not the case, then you have to keep charging. You have to make sure that battery lasts long enough. And then when you're not using it, somehow there's a time window, then you can charge it. And then one more way is to maybe you can find out how to optimize the processing and data transmission so that the power consumption goes down, right? So these are different things you can do. Resolution is also important, for example, not necessarily in video, but in all other cases, because we are making those devices small to consume low energy. So that means since sensor size is small, then many times it's not possible to make a very high-end sensors with high resolution. So now consider you're using the AR headsets or VR headsets, then you have maybe you're seeing everything pixelated, right? It's not very clear. But if you now look at a TV, like very high-end super high resolution TV, 4K TV, then you'll not be able to see the pixels, right? Because there are some limitations in the hardware. But you'll see that the technologies are getting better. The cameras are getting better, the display technology are getting better. So I think there'll be a time when these differences will be gone. But of course, this is one of the challenges that we have right now. There are some, of course, for example, the wearables where actually you're wearing them as a cloth. In that case, you have to, if you put a lot of sensors, it will be very heavy. That will not be comfortable. But if you reduce the number of sensors, then basically you have to use very complicated algorithms which might not be as precise as when you're having a lot of sensors. Safety is a concern because they may radiate some of the kind of frequencies, radio frequencies, which might not have some negative. It might have some negative impact on our health. So those things we also have to take care. And security also. Now, since all the things that you have to expose to the network, and then they need to make sure that no one can hack them, no one can steal them. And then now you have one more thing to think about, that how can I keep it secure? So these days, which are like a high-end IoT kind of wearables, they make sure that they take all the possible care so that your data is secure. But again, only to some extent, you can believe it, because for a person who is not tech, from a tech background or tech savvy, he will not be able to understand what is going on under the hood. They might not be actually stealing the data, maybe using our data without our permission to do some modeling, training AI model, right? Regulations are also issue because personally, like when we were actually building that AR helmet, for example, we found issues because when we were trying to take it to the Europe, then we found out that in Europe you have to really go through a lot of paperwork regulations before bringing a kind of helmet, kind of a headset that has a camera in, because that means your privacy issue is there and regulation is there. So all these things are very strict in Europe, for example. So I found that is very tricky. But if you go to like US or Canada, things are not that strict. So regulations are it's not that difficult, not that very kind of restricting. So depending on the location, those are challenges are also there. And that is also true for other wearables. When you have to take different certifications, it may take time, and they may not allow it in a particular area, and all those things might happen. Privacy, of course, is an issue. You don't want someone to steal your location. What is your vital signals? Maybe they're using it for some other purposes. So those things we have to take care of. So I'll stop here. So I hope I was able to give at least a brief idea about different kind of wearables and how IoT comes into picture. So I'm not talking about a lot of IoT because these topics are being covered in the other lectures. But I hope this was useful to you. Thank you.
Thank you, sir. Thank you for this wonderful lecture. So now we request the participants to please ask your queries in the chat box or Q&A section. You can also interact with the expert. For that, you need to raise your hands from your end, and we will unmute you in the session. Thank you. So Nancy Soni ma'am says, thank you, sir. Nice presentation. Thank you.
Thank you.
One participant has raised his hand. So with your permission, shall we unmute him, sir?
Yes.
Please give me a minute. Gulab Patel, we have unmuted you.
Yes, ma'am. Yeah. Hi, sir.
Hi.
Yeah. So my question is another question. I just want you to brief a vision sensor, but before that, I have a question. that is quite related. Suppose the problem is optimal resource allocation. Suppose there is a manufacturing unit and raw materials, or you can say raw packages are coming in and we need further processing. And suppose there are some machines, 4 to 10 machines that you can allocate. So what technology we can use for the allocation? Can we use IoT to count the incoming packages, and if the per hour or per unit time,
Right.
whatever you are using, uh,
Yes.
increases, then you can allocate the resources, or you can use the computer vision to count the queue length or is the machine, and if they increases by certain threshold, then we can put more machines in the machine.
Right. Right. So these are
And
different ways
second
of
thing,
doing it, right?
yeah,
Yes, go ahead.
just
Yeah.
one second. Yeah,
Yeah.
and can we use vision sensor? Because I don't know what is vision sensor, how does it work, so I'm not able to relate. Yeah.
Right. Yes. So in general, what I want to talk about, so one of the projects that we did was we used a 3D time of flight sensor. So basically a time of flight is a technology that you can use to, there is a kind of 3D sensors where actually can find out the depth, okay, from the camera. So we used an array of time of flight cameras to find out the dimension of a package. For example, say you have a square kind of cube packages, you can find out length, width, and what's the height. So those things is possible to do. And this is a bit more complicated task because now you're actually looking at a 3D volume. But if you want to count, for example, so you can definitely use some cameras. For example, you can use even a single camera you can use, and that can basically, for example, a color camera. That color camera will be installed. For example, there's a build, right? All the packages are coming. I'm just giving an example, and you have to count how many packages are coming, which is important for you, because maybe you find out that there's no packages coming, and then maybe that signal that no packages are coming. What is the problem? Those things can be maybe sent to some of the one who is monitoring the whole factory site or manufacturer's factory site. So those cameras. Some of the components that you will be required when you're building those system will be one. You need one camera. You'll be needing one computer, right? So that it can be connected. The camera could be connected to that computer, and that computer can be actually not necessarily what you think about a workstation. It could be a simple embedded, kind of a single board computers. There's kind of Raspberry Pi, for example. Those are different computers you can use. So it is these days it's pretty easy to even you connect any kind of vision sensor to those Raspberry Pi, or there's some more advanced ones I can tell you. Those are Jetson Nano, for example. It's a very small sized single board computer that you can use. You can install any kind of OS you want, and then you can just connect the camera to it. It's in Linux. You can just run the camera, and then basically that vision camera will be sending you all the video feed to it. And there are kind of packages like OpenCV. OpenCV can be easily integrated, can be used to read the video feed and then do some computer vision algorithms. And these computer vision algorithms can be either written by you, or you can use in some of the Python. For example, OpenCV in Python can easily use some existing Python libraries that can use a lot of
Yes.
computer vision algorithms, right? And one just last thing I want to add is that this Python libraries are I think it's the best way to go, like, because a lot of the computer vision algorithms that we have used in our projects also, for example, a lot of third-party software, you don't have to really buy some expensive software. If you know how to code, you can just get those codes from GitHub and use it.
Okay. Okay, thank you so much. So, if we want to improve the model performance, means system performance, so how feasible it would be to put the sensor on all the packages to monitor them?
Right. See, one of the things that I haven't mentioned here is that I didn't mention is that when you're using a machine learning model,
Yeah.
you need to train it, right? So
Right.
data.
Yeah, right.
So many times what happens, you don't have the data to start with. That is the problem.
Yeah,
So
it
in
is
that case,
always a
what will
problem.
happen is, yes. So one thing I want to say is that don't just jump to AI or machine learning just because everyone is doing it. Okay.
Yeah.
If you have some good sensor, just doing some classical, mathematics will help you. right? For example, when you are, say, for example, you have a camera, a 3D camera, and then you want to find out what is the size of the box. So
Yeah.
if you use color cameras, then you will need multiple cameras, right? You need 2, 3 cameras, then you have to get the images, reconstruct 3D. But these days there are a lot of very cheap 3D cameras. Just one camera is enough. So in that case, all problem is solved because you're getting the 3D. You just figure out, from the depth map, okay, what is the height of the middle point, what is the height of the corner, so that is the height of the box. Those things can be done. So always I will suggest that things simple. If things can be done in the hardware side, a lot of problems in the software will be solved because you don't have to compute all those things. You don't have data. So if you just want to find the height of the object, you just use a depth camera and you can find the height, right? So you don't need to do any multiple camera stereo systems, do some AI on computing field. You don't require it. So you have to think in both way, like a very smart way, okay?
Okay, yeah, got it. Yeah. So,
Yeah.
okay, one more thing. Is this vision sensor, what is
Mhm.
vision sensor? How we can use it if we need here?
See, vision sensor is nothing but what we call as cameras. That's it.
Okay, got it.
Okay, it's a different kind of cameras, color cameras, 3D cameras, infrared cameras. And once you have those cameras, you connect to your computer, it will be able to access what this camera is capturing, right? Whether it's a depth data, it's a color data, it will be a 2D matrix, right? 2D
Yeah, got
matrix,
it.
maybe multiple channels, depending on if it's color camera, it will be red, green, and blue. But those data basically you can use with some image processing algorithms, for example, to find out
Mm-hmm.
edges, corners, and some other features.
It
So
is,
that's what
yeah.
I was talking about when talking vision sensors.
Okay, yeah, got it. Yeah, thank you so much, sir. Yeah, thank you so much.
Welcome.
Thank you, Gulab Patel. Next one participant, Mr. Sanjeet Kumar sir has posted his question in the Q&A section. So shall I read it, sir?
Yes, please.
Yeah, how AR, VR things in IoT are different from the normal IoT things in terms of communication technologies and in terms of cost also. Do we need higher computational complexity for AR, VR things in IoT?
Yes. So it's a very good question, actually. Regarding the first question, uh, so if I define normal IoT as some kind of IoT system based on some sensors in your home, for example. Okay, you have a smart home, you have some sensors out there, in your fridge, maybe in somewhere, the temperature sensor or some other devices. But most probably they are collecting some one-dimensional data, right? This is time series. For example, maybe it's just calculating some numbers like temperature, how it is varying over time. It's just one number at every some sampling rate, you are computing it, or maybe some other humidity, or maybe some kind of battery, what is the status of the battery, charge of the battery, all these things you're collecting. These are 1D signals. But in AR, we had a problem, the challenge comes because we are dealing with many times with a video feed. Okay. Now, video is a very complex data because, its size is big. And then you have to, when you want to send the data, you have to use some certain protocols. You have to, stream it. You have to compress it. So all these things will come into picture. That means it also brings to the second question of yours. The computational complexity will be higher when you're the AR VR things, because now you're dealing with images and videos, and many times your AR VR might have some 3D cameras. So then you're also dealing with 3D data. So definitely the competition will be higher. And I just want to point out, like, for example, Amazon has a kind of library known as IoT Core that I already mentioned. So they know these challenges. They are making some special versions of those just for AR and VR, so that they know if someone is sending a data to the cloud. If it is simple temperature data, for example, they have some other kind of protocols. If they're sending the video, they have given some very optimized kind of APIs that can convert your video to a particular format that can be easily sent over the network with low cost, because somehow they will compress it in such a way that you don't have to send you can only send this compressed data, and then you can reconstruct it back to the cloud. But of course, the computational complexity of AR VR things will be higher because we are dealing with 2D or 3D data.
Thank you, sir. Thank you for solving all the queries. So with this, sir, we come to an end to all the queries of the participants also. So thank you, sir.
Thank you.
Thank you for joining. And
You're
on
welcome.
behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya sir, and entire team of all the E and ICT academies. I thank you, sir, for accepting our invitation and coming on board and sharing your knowledge with us.
Thank you very much. Have a great day.
Yeah,
Bye.
same to you, sir. Bye. So dear participants, with this we come to an end of this session 1. So shortly we will start with the next session, which is hands-on session 5, conducted by IoT Academy. So we will start the next session from 12:30 onwards. We will have a short 20 minutes of break. So we request all the participants to please be online, not to disconnect your system. We will start by 12:30 again. Thank you. Thank you all. Hello, am I audible? So, dear participants, we welcome you in this second session of day 6 of this online faculty development program. So, we are waiting for the expert to join. So, once he joins, we will start the session. Thank you. Hello.
Yeah, hello, ma'am. Am I audible now?
Yes, sir, you're audible, sir.
Fine, fine. Okay.
So, we have given you the presenter, right? So, we
Mhm.
request you to please test the sharing option once.
So, ma'am, is it visible to you, my screen?
Yes, sir, your screen is absolutely visible, sir.
Okay, fine.
So then, shall we start, sir? The second.
You can check that number of participants if they are
Yeah,
available.
yeah, there are total 267 right now. So I guess we can start, sir. So welcome all the participants in this second session of day 6 of this 2-week online faculty development program on IoT and application. So today, now from 12:30 onwards, we will be carrying out with the hands-on session number 5, which will be conducted by a new expert, Mr. Kaushalendra Singh Sisodia, sir. Before we start, we will have a short introduction about the next speaker. Mr. Kaushalendra Singh Sisodia, sir, has 20 plus years industry experience and co-founder of the IoT Academy. Prior to this, he played various key roles in Ericsson AB, Sweden, ST Microelectronics, and other MNCs. He has been chosen by the ATL Mission Niti Aayog, Government of India, as mentor for Delhi Public School, Noida. Kaushalendra sir is IIT Kanpur alumni. He is a veracious speaker and delivered many talks uh, uh, in universities and colleges on Internet of Things, Industry 4.0, convergence of technologies, and startup ecosystems. So, with this introduction, I welcome you all. I welcome you, sir, in this platform for delivering hands-on session number 5. Over to you, sir.
Okay, thank you, ma'am. So, good afternoon, everyone. Welcome to day 6 on joint FTP for IoT and applications, smart systems. So, today's topic is IoT based GPS location tracker, and we would be doing some experiments based on the GPS. So since this is a hands-on session, I would like to have more interactive session from both sides. So let me check that how many people are very much aware about the IoT, or sorry, not IoT, about the GPS, how the GPS works in context of IoT. So uh, please write down in the chat window so that I can check.
So, dear participants, you can use the chat section as well as Q&A section to have a text interaction with the expert.
Uh, Somehow, ma'am, I have okay. Where is this window gone? Where can I? Okay, so people say that they are already aware about the GPS and IoT. So that would be really helpful. Uh,
Yes, one of the participant, Anand Kumar sir, has privately messaged. Please enlighten us.
okay, fine. So we anyway we would be discussing all the things today. Ma'am, somehow I'm not able to see this window. How to check, because that window is not coming in the Q&A session, so that I can also check. Do
Sir,
you know?
on the top of the screen, once you take the cursor, there will be a drop down. From there,
Yeah,
you
it is
can.
somehow it is not coming. Why it is not coming? That's what I'm just wondering. This window
Sir,
is generally
you
should
can.
come, no?
Yeah, you can do one thing, sir. You can stop sharing and then check.
Correct, correct. That I should. No, but that window for stop sharing is also not visible somehow.
Yes, sir. You need to take your cursor on the top of the screen. Then
Yeah,
a drop down menu will come.
yeah,
In that,
it should come, but it is somehow not coming. That's what I'm thinking. It should come, but it is not coming. So it would be
okay.
a problem then, because ending should what it is saying. Let me.
So you are using Windows system.
Checking. Yeah, I'm using Windows, but generally it used to come, but something has just now is stopping it, I guess.
Okay, I will stop sharing your screen from my end.
But yeah,
Yeah, we will reshare again. Okay, sir.
okay. But still, I should get that window so that I can share it. Otherwise,
Yes, sir. Yes, sir. You will get it. You will get it, sir. Please give me a time.
or I have to. Okay, now it has something has come. Yeah, now it has come. Good.
Sir,
So
sir, you are right now not the presenter in the in the meeting. So I'm
okay,
again making you the presenter. You share again, sir.
okay. I will. Yeah. So please make me presenter.
Yes, sir. So now you are the presenter in the event, sir. You can again share.
Okay, I will share. Okay, fine, fine. Yeah. Okay, it is fine now. So let me check the Q&A chat window. If it is, we know about GPS and IoT. There was from Manju Chaudhary, ma'am, and then okay. So one or two people have mentioned that they know. So I will take from the basics. So we will start uh, with the with some use cases. So everybody is aware about some use cases like school bus tracking system there where we use GPS system, right? So the parents can automatically see that their kid who is sitting in any bus, where is the bus going and what is the route being followed. So this is the one use case you have seen. The smart transportation, we use a lot of things that the vehicle owner, he wants to know that whatever has been ferried from one place to another place, what is the which path it is following, and the items, if it is carrying a raw item or the perishable item, are they in a good shape or not? So that kind of sensors, using the sensors, they will keep on tracking few parameters like temperature, humidity, or if like some fruits are going, then probably they will monitor some gases also, that what kind of gases are being generated, so that they can know the freshness of the foods. So it is being used in supply chain system. Then traffic management system for the local authority, they can check or the people who are running some buses or the traffic controllers, They can check that which path there is more traffic, and they can pass on information to various travelers so that they can avoid using that particular path. So this is used in traffic management system also. Fleet management for the government and private bus systems. At the bus stop, the passengers can know that what is the arrival time of any bus, and like lot of information they can. So in developed countries, this is very much being followed. So they can know that what is the frequency of any bus, and what time it would arrive at the bus stop. So this kind of information is also being used, and solid waste management system in the smart cities. This is also very much used. And some other cases like fishery, it is used, agriculture, forestry, and the public security. So these are the some use cases where we use GPS. And there is one more interesting GPS use case that is used for underground cable and pipe locator. As we know, the in the under the ground, what kind of pipeline do we put, or the wiring we do? We use gas pipeline, telephone cables, internet cables, optical fiber cables, electricity, water pipe, sewage pipeline, underground transport system. So these kind of things are happening under the ground. And how do we know that if like some electrical cable is already going somewhere, and some other utility also wants to put their cabling, or they want to put the pipe, and they start digging, and there is a chance that electrical wire can be destroyed, or it can be cut, and it can be like disastrous for, or maybe the gas pipeline, if it will be uh, it is cut due to some mistake, then there would be a big loss for the humans, as well as the wastage of the gas that would also happen. It can happen, and it can cause the fire also in some cases. So this is very much important to locate and to put the information for each pipeline and the cables, that how they have been put under the ground. So whenever a new vendor is coming and they want to do digging for their own utility, they can check that what are the pre-existing wires or cables are going inside, and at what level, what place they can do the digging, and they can put their own utility cables, wire, whatever it is. So here we require a lot of positioning system that is accurate up to few centimeters of like error. So this is very interesting use case, and it is being very much followed in the developed countries, where they can get all kind of information about the underground utilities. So this was the some use cases we have discussed. Now we would discuss about the positioning system. So GPS is basically a specific case. If we talk about the generic term, that is called positioning system. How do we position a particular object? So if we discuss about the positioning system, since GPS is very much replaced by positioning system, everybody talk about GPS, but this GPS is used by USA. So this is USA technology that has been deployed by installing the satellites in the Earth orbits. So basically, there are problems about from the positioning system point of view. The most accurate fitness-oriented GPS device at their best performance are accurate to around 3 meters. So whatever the best device we can take for GPS, generally it is 3 meters accuracy. And if we have to have some centimeter accuracy, then we need some assisted hardware, so that we can get up to centimeter accuracy. In the case of the underground pipelining, we need centimeter accuracy. So the simple GPS receivers will not work. We have to do something extra in the hardware. And this is very much agnostic to the disturbances or the interference from own signal, or from the shadowing, or the multipath, or some other kind of obstructions. So if there is like underground, if we have put GPS, whenever we go like underground parking, the GPS signal reception becomes totally unavailable. There is no availability of GPS. So whenever there is a obstruction, it will not be received. So for underground cabling, how do we do it? That is a different way of doing it. When we are laying down the wires or cables, at the same time we put the we map it to the IT services in the IT domain, and we save all the data in the database. So that is the way it is done for the underground cabling. But in general, whenever we go for basement to check the GPS signal, it is not available. So whenever there is a line of sight proper, then only we can get the good signal. Otherwise, due to disturbances, uh, there could be problem in the accuracy of positioning. Other problems with GPS is, as we discussed, there is a multipath error, then we cannot get the proper positioning. There would be error in positioning due to the signal obstructions. And like other problems is that we don't have the enough satellites. So if to get the best positioning information, we should get up to at least 7 to 8 satellites in the focus of the GPS device. Then only we can get the exact location of the GPS device. Otherwise, there would be a chances of getting error. So if we have less than 4 satellites, then there would be error in the GPS signal. Generally, we see that GPS signal loss, it happens when the satellites that are in the range of that device are not more than 4. Then we see that GPS signal loss is displayed on our mobile. Whenever we use GPS information for locating any place, and we are going, and sometimes we see there is a GPS signal loss. So that is the time when the number of satellites in its visibility are less than 4. The other problems with GPS is that it takes some time for initialization and warm up. So the first time when we do the initialization of the GPS receiver, it downloads all the information from all the related to the satellites, and it takes at least 5 to 10 minutes for the first time for getting the proper information about the positioning. Cold start is the one when the first time we do it is the same thing. The first time when we do it is called cold start, and the warm start is when at least once we have done the we have initialized the GPS, and the subsequently we are using GPS. So that is called warm start. That takes less time in compared to the cool time. So here it again sync up with the various satellites, and we get up-to-date information for the satellite positioning and the timing. Assisted GPS is one another way of doing it. We like in our mobile is having assisted GPS. It is having one GPS chip, as well as we are having the cell information that is coming from the 2G, 3G, 4G, whatever network we are using. So from that network, we also get some information about the positioning, and that information is fed it to the GPS device. So it reduces the total cold or warm up time if we use a GPS, assisted GPS. And this we have already discussed, the signals of obstruction and the multipath error are the issue. So whenever we are traveling in the mountain area, there could be, if there is a steep mountain side, causes temporary loss of the GPS signal. So this is one of the problem with GPS. And whenever there are huge dense trees covering coverage is there, again in the dense area, the GPS signal will not be available. During in the urban area, due to the tall buildings, again due to abstraction, we can lose some GPS signal. So this was the problems that we have discussed about GPS. There are some other facts about GPS that we generally call 2D fix and 3D fix. So 2D fix is for 2D fix we need at least 3 satellites, and here the information would be only for in 2 dimension. 3D means we would be having information about height also. So here we need at least 4 satellite to get 3D fix. So most of the time the devices that use the GPS information or driven by GPS information in some of the embedded devices for the clock reference we are using GPS devices. So until unless we don't get the 3D fix, the clock sync will not happen. So we have to have 3D fix in that case. Here we would be having the 2D as well as the height also, the all the altitude, latitude, longitude, and so all the 3 dimensions are required for the three dimension positioning. So if we, okay. So this is the thing, GPS constellation happens like this. So this is a place where if I talk about, so you can see the visible satellites are changing time to time because Earth is also moving and the satellites are also moving. So even if that particular object is stationary, the number of visible satellites will keep on changing because of the mobility of Earth as well as the satellites. This is GPS. GPS is done by USA, and the another positioning system that we have is Galileo. Galileo is owned by European Union, and they have launched 24 plus satellites by 2021. That they have already completed the installation of the satellites. Another one is GLONASS, that is from Russia, and they have also fully operational 24 plus satellites. GPS also has 24 plus satellites. Then the Beidou is Chinese one, and here they are having 35 satellites operational. So here you can see in they have launched the satellites in different areas. Some are the geosynchronous like orbit, and some are low geosynchronous orbits. So they have launched in the satellites in multiple orbits so that they can have the proper coverage of the Earth. So this is the around the Earth, and this is the polar view, and this is the another view. India has also launched satellites for having its own positioning solution, and it is called IRNSS. And the chipset that they use is called NAVIC. So navigation with Indian constellation. That's what they say, NAVIC. And total they have launched 9 satellites so far. 7 are working and 2 are in the non-working condition. So this is the way it is around the Earth, how they are rotating, and the polar view is like this. And since NAVIC is already there, so it is responsibility by the different chipset manufacturers that they provide the chipset with the respective positioning solution. So Qualcomm has launched with their 3 chipsets, Snapdragon 720G, 662, and 460 with NAVIC chip. So in this platform, you will get Indian positioning system. So this was basic uh, about the GPS problems, the facts, and the different solution that different countries are providing. Now we discuss about the architecture, a brief architecture. How does it work? We have a GPS device. In GPS device, when we have, it should be having it is in terms of the solution when we make some product. So when we make a product based on the GPS, it would be having one controller also, and another other than controller it would be having some sensors also. So we would be having sensor and interface board where we can have different parameters that are being measured. It could be temperature, humidity, air quality sensor, gas sensor, and gas sensor it could be CO2 or CO2 sensor with digital or analog input. So these are the different sensors that are being like fetched by a controller, and by using GPS solution, GPS information, and 2G, 3G, 4G, they will transmit this information to a server. So here the cloud, we would be having some cloud MQTT broker, or we can have some other protocol also, HTTP also we can use for sending this data. But in IoT mostly we use MQTT, so MQTT would be used. And here the data would be sent to the server, and server we would be having a database. So all the sensors and the positioning information would be stored in database, and using the desktop or the mobile app we can access and we can monitor the positioning and the other parameters uh, of the device that is being carried by a particular vehicle. So this is a typical architecture, and generally the server programming, this side the programming is done in Java, Erlang, or Go. These are the typical languages that are being used. And here in the GPS device, we use generally C programming, C or C++. Sometimes if somebody is using Python can also be used, but C, C++ is the majorly used. So we would be doing the hands-on based on this one. But since nobody, like people would not be having any GPS device, but one GPS device everybody has, that is their mobile. In mobile, we have various sensors and we have a GPS installed within this. So we would be having mobile sensors are already there. You can see the picture below the line, how we would be performing the hands-on today. So in the mobile, we would be installing one client app. That would be what would be the responsibility of this client app. It would be capturing all the information from the mobile. Right now, we are interested only the positioning parameters, but it can capture other parameters also, because in our mobile there are a lot of sensors. Whatever sensors we want to map, that we can capture. But right now, client map app is mapped to get only the positioning information and some other information like speed and other things that also it captures, and it sends to the server, and we will see all the information using a browser. So everybody in this webinar, they should be having a mobile as well as a laptop so that they can perform the hands-on session. The mobile will be used as a GPS device, and the laptop we would be checking the location using the server side, and we would be opening it in the browser and we would be checking it, and we would be doing some kind of operation, some data analytics at the server side. So I hope everybody is having one mobile as well as a laptop with them. So this is a typical GPS device I have put just for your reference. Here we would be having some power on off indication, SIM card slot is also there, power interface. There would be some kind of data interfaces also. It will carry some kind of sensors information. A mic interface can also be there. SOS is also there, and something related to the engine information we can also map to different wiring, different digital and analog inputs we can send using the GPS device. So when we would be doing hands-on, before moving to that one, we should look into that what would be our learning, what is our problem statement that we are going to solve when we make any GPS based positioning solution. So the major issues that industries are facing or the individuals are facing, that is the fuel pilferage. Whenever there is uh, a transport company owner, their drivers generally steal or they do the fuel theft sometimes. So how he's like very much interested to know how much filling was done for the fuel and how much consumption happened during a trip. So fuel pilferage is a major issue. Security sometimes, like we hear a lot of news about the vehicle theft. So how we can minimize the theft situation. Billing, if there is a transport company, they would like to show whatever distance that vehicle has traveled. and how much per hour kilometers they have mentioned. So what is the final bill for that one? So that they can give the itemized bill as per the actual kilometers. Then productivity monitoring. So there are a lot of people that are in the field, either it is sales people or some other people. So where are they moving? Are they really at the client location or they are going somewhere else? So that productivity monitoring can also be done if we know the position of each and every resource. Driving malpractices. So if some driver is doing over speeding, that kind of information can also be can be can also be captured. Monitoring of raw items. So whenever there is a transportation of raw or perishable items, we can do the monitoring of that. So these are the few things that we have mentioned, but there could be enormous use cases, like enormous problems that we can address using the different use cases. So what are the solutions for the problem that we mentioned? So we would be monitoring the parameters, and based on the parameters monitoring, we would be generating events and notification. Like if there is a overspeeding, we can generate immediate that the particular vehicle has overspeeded. Or we can have the second point is the geofence. So we can create a geofence around its normal position wherever it is. Like in the night, we have parked somewhere a vehicle, and we can put a geofence around it. Whenever the vehicle will go out of this geofence or come inside the geofence, there would be alert or notification given, so that the owner of the company will know that this particular vehicle has left. Or geofence is also very much useful for the school bus management. Whenever the school bus is starting at from a particular position, immediately immediately the alert will be sent to the parents who would be like dropping their kids, so that they can minimize their waiting time. So this way geofence is quite useful. Reports whenever like some owner wants to check what was the total transportation time, or whatever was the waiting time at a particular trip. So all these kind of trips they can all kind of reports they can generate using the data that has been saved in database. So reports are very important. Sometimes we need information of any vehicle that up to six months. So that kind of information can also be stored in the database at the server side. The fuel mapping, how much fuel like was filled and how much it is consumed. Speed limit, fuel consumption, it is okay, same thing. Temperature, humidity, vibration, gas, this kind of parameters we have to monitor so that we can like avoid the wastage of raw items. And other parameters, if there is any other parameter that has to be monitored, that we can also do. So now we have to move on to the hands-on session. So I hope that everybody has a mobile with them, and everybody has to know the IMEI of their mobile. So everybody knows how to find IMEI of their mobile. Please mention it in the chat window. If they don't know how to know the IMEI, I can tell. Does anybody know that how to get IMEI? Or who does not know, please tell that part. Okay, so people don't know about the IMEI. So what you have to do, I have here shared my, I have one screen for my mobile. Okay, I have to do reconnection. So here you can also check my mobile. Let me open it. The people who know how to find the find their IMEI, please find it out and please have a note of it because we would be needing IMEI number for tracking the GPS device. Somehow my mobile is a little bit slow. Just trying to connect. So this is my mobile screen. You can everybody can see this is I have mapped on my laptop screen. So if you go to the settings like this, if you go to the settings, it is little bit slow. It is reflecting little slower. It is okay. So please go to settings in your mobile and come to the last point, that is about phone. Go to the about phone. You would find in the settings about phone, and here you would be seeing two IMEI. If you are having two dual SIM mobile phone, you would be seeing two IMEI numbers. If you have only single SIM, then you would be having only one IMEI. So please take the IMEI of your slot one, which one you are using mostly. So please take down this number. This is a almost 16-digit number. Let me check. 948. It is 15-digit number. Sometimes it is 16-digit, sometimes it is 15-digit. So in probably some people would be having 15-digit or some people would be having 16-digit. So whatever number you have, please note it down in any notepad. Like I can note it down here for myself. 3540 550 911 62160. So this IMEI number is needed because we have to track our mobile. So it would require a kind of identifier through which it can know that what is the GPS, which GPS we have to track. So IMEI is the number that through which it generally tracks. So has everybody found the IMEI number? Anybody is there who has not found the IMEI number yet? Okay, so Jam ma'am has told that you can also do this hash like star hash 06 hash IMEI. So probably this will also work. So the people, if they can dial this one, they can do it. So probably you can try this one. The one ma'am has told, Jaya Sharma has told that you can use hash zero. Let me try this one. I have not used for some time. So if you go to the dial button and you press star hash 06 hash. So as soon as you do this thing, you will get the IMEI. That is also one way. You can see that I have done. So I got this kind of screen. As soon as I put this code in the dial number one. So star #06 hash. This code you have to use. You will get immediately the IMEIs. I hope everybody has got IMEI by this time. Please, it is important that everybody get the IMEI. IMEI is like one option is this one that you dial this number, or you can go to about phone, you will get easily. Settings you generally know, right? Settings you go and then you have to uh, go to about phone. That is also one option. So if you go, generally this is the way you have your mobile. Let me let it come. This is the way you have your mobile. If you scroll from up and you do like this, you have a button over here, this this button, and you have to click this button for the settings. So as soon as you do the click this button, all the settings will be displayed, and you have to go little down, and there you will see that about phone. Almost it is in the end about phone, and you have to click it, and you will get the IMEI information. Like how many people have got the IMEI? If you don't have IMEI, cannot complete the hands-on session. So Ananya Mukherjee ma'am, have you got this IMEI? Okay, you got it. So now one step is done, that we have got the identifier with which we can continue our like GPS tracking. So now the second step is, as we mentioned, I go back to the slide here. The second step is we have to download TechR client, because we have to get the data from our mobile and send it to the server. So we have to install a TechR client in our mobile. So we have to go to Play Store. Please go to Play Store. I will show here also. Go to Play Store and find TechR, TRACCAR TechR client. You have to find in your Play Store TechR client, and you will see this green color, this kind of uh, like logo, and here you have to click it. You have to find the tracker client and click it. You will get this kind of window. One tracker client you will get from Anton Tana Nev, and since I have already installed, it is showing me to open it. But the people who have not installed, it will show the install button here, and they have to click it so that you can install it. If it is asking for any do you believe or do you trust this particular app, please select yes. So it is safe, it is not any problem. You can install this app in your mobile. Yeah, it will show this application malware. Is it okay to install? So yeah, you can select it and you can install it. This is a generic problem. Generally, Android phone, generally they think it is a malware. So as soon as you have installed, please let me know. Sayyid Ali, have you installed it? Okay, Sayyid has done it. Anybody else who has done it so far? Okay, Gulab Patel has also done it. So Jaya Sharma has also done. So I assume that other people have also done. So one thing that we have shown in this PPT here, we have mobile, we have sensors, and we have put the client app. Okay, so client app is we have installed, but we have not made ready because it will start sending data to the server. So the client app has to know the information about the server, then only it will send the data to the server. So we have to do some configuration in this client app so that it can do it. So I will uh, before going further, I can show you how the server will look like so that you can have some idea. So if I take you to the further, so this thing you have already tracker client you have already installed. I will show you how to do the further setting, but before that, I can show a few more things. So after the client is installed, we will go to the server side. So server side where we would be doing the GPS tracking. All the information would be from various GPS devices will be sent to the server, and there we can do the monitoring of that particular device. So the the server would be will look like this, and here we would be doing some kind of the geofencing. I will show how to do it, and we would be doing some overspeeding alert generation, and we would be creating some kind of reports that we discussed, like we have to see the report for the last 7 days or last 1 month, 2 months or 6 months. That also we can do. And this is the free version, so it would allow you to do some restrictive things. So you cannot use all the features, but up to like lot of features you can still use. So this kind of thing we would be doing. And we will be seeing the alert and notifications. Some alert and notification will happen. So now we come back to the client. You please open the tracker client now. Since you have installed, now open it. I will also open in my mobile. So I'm going to open it now. You can see on my screen I have opened it. So as soon as you open it, it will show this kind of window. So here the first one is you will see that service status is stopped. So because we have not started the service, but before like starting the service, we have to do some settings. So we would be doing the device identifier. So here, if you double click this one, device identifier, if you click, you will see, since I have already configured my IMEI number here, now you have to put your IMEI number in this field. So basically, I had checked this was my IMEI number, so I have used the same number in this field, the device identifier, the second field after the service status. So please write it down, your device identifier. Please count the number of digits and match it. If any digit is not matching, you will not see your mobile location on the server. So if it is done, then we can say OK. So you will see the device identifier is set. Now we have to do the server URL. So we have to set the IP or the URL of the server so that the client can send information to the right server. So if you click it, I don't remember what would be the default value, but you have to put this value now. HTTP, I can send it over chat window. So everybody should copy this address, uh, demo4.tracker.org colon 5055. 5055 is the port number, and this is the server URL, demo4tracker.org. So please put this URL in your server URL and press the button OK. So these are the two minimum things that are required for sending the data. Other things are also configurable, like location accuracy, how much you want to put, what is the frequency, how much frequently you want to send data from your mobile to the server. So it can be in it is in the interval of seconds. So right now, if I show you what is my frequency, you can also check your frequency. It is 10 seconds. So every 10 seconds, it will send data to the server. In your case, you can also check if you want to have 10 seconds, 20 seconds, so you can do it. Please check what is the frequency in your case. If it is, you can change it also because it is editable. Other things we will discuss later on, but let us do first check this one. Now there is a button status. You can just click this button status. So it is right now there is no information. I see when I click the status button, there was nothing here, right? I can go back. I press the back button and I will, since the service is still in the stopped condition, we have to start the service. So please make the service running. You just click the button so that it comes to the green side. So now service has started running. Now if we again go to the status, check the status, you can see there is a some text is there. So service has started and network has become online. The second, we have two kind of information. So do you see, have you followed up to this point? Is your service running now? Please write down in the chat window. And do you see the service started and network online, this information? Okay, good. So now at your client side, things are ready. Now we will go to the server side. Okay, so now you have to use server that we have uh, done. Either you can use gps dot the IoT academy dot co. This is also okay. So you have to check that Sayed, are you getting, like, are you connected with the network? Anybody else is facing this issue, send fail? Send failed, why it is coming? Because I have never seen this issue. Okay, send field is coming. So probably you have to allow this. I have done something. Send field. Let me try in somebody else mobile also, because I have done earlier. So I have not faced this issue. One thing you can try, that you can go to the app management, and there you can allow for accessing it. Let me check in the app management if what happens. Just a second. मुझे दिखाना एक सेकंड. इसमें प्ले स्टोर, where is the Play Store? In the meanwhile, please, I will check in the another mobile. So please go and create your login on GPS, the iotacademy.co. Please visit here, and it would ask for the. It would take you to the different. You have to like do like this. It would take you to this web page, and you have to put your email ID, enter your password, and you have to click that remember button. Since you are first time doing, so you have to do the register button, you have to press. And please remember, since it is a demo server, here if you forget your password, there is no possibility to recover it. So you have to use another login. So better to remember the password. You have to note it down the password, because there is no forget button here. This they have not given. So it is a free server for the demo purpose. So please do this step. By that time you go to your laptop browser, and there you can access this web URL. And after getting this page, you have to create your login. And after the people who do register are able to register, please log in also. तुमने किया था क्या कभी? Okay, good. So the people who were facing issue to do, can you like enable your location, the GPS location? मैं तुम्हारा भी आ रहा है क्या? Please update your location services, and then go back to कैसे होगा? And फिर आ रहा फिर से? हाँ? Okay. Okay, so if you enable your location service, the GPS service, and please stop the service again and start again. So if I show you here, we have the location right in the sensor. So you have to enable this location, because we have to send the location update, and you have to go back to your client, go back to the client, tracker client. You stop it again and then restart again. So service status, you stop it and then start. So make sure your location is enabled there and you have given all the permissions to this app to send the data to the server. So if you go there and then if you will check, uh, you will see that network is live, and as soon as you enable the location, it will start sending the location update also. So you have to see that location update is also going. And you will see that it would be sending every 10 second, almost every 10 second. So after 57, the next would be sent on the 07. So you can see that every 10 second, the location information is sent from the mobile client to the server. Okay, इसके में फिर से तुम्हारे में send fill आ रहा है. So there is, I think there is, when you see the send fill issue, there is some internet issue, like you are not having the proper coverage. Because in another mobile, I also see this issue coming. And field location update had gone once. Anybody is able to see the location update coming in their mobile? Okay, so sometimes update is happening. So there is some internet issue, but sometimes if update is going, that is fine. Because we even one packet is going, it should be okay, because the server will capture it. So let us try. We will go to the server, and so if I also open the server at my end. So I'm opening server at my end, GPS. IoTacademy.co. So I will also log in. I will log in. I have my employees login because I have already exhausted my email ID. So I will log in now. So you will see this kind of page coming, right? So you will see this kind of page. So here you would be seeing one device section at the left hand side, top side, and then down it is state. And in between, if I remove the event this side, you would be seeing a map here. Right hand corner, you would be seeing event. So if you click event, it will show like this. You can see the different events coming here after we create the events. And then the down, you would be seeing a report. There is a one blue bar, and there you would be seeing the report. If you click this one, the report another window will pop up, and we will be able to see the reports. If you want to bring it down, you have to click again the down button, this down arrow. So now what we have to do, I have already mapped my mobile here, so you can see my mobile coming up here. Just a second. Hello? Yes. मैं बाद में बात करता हूँ मैं बिजी हूँ किसी में so since I have already mapped and my device is already online if you would not be seeing anything here you have to go and first we have to map our mobile or our device or we have to register our device in this server so we have to click the plus button add button so you have to press the plus button and you will see the new window has pop up here you have to write a name like you can say my mobile as I have done my mobile and you have to put the identifier so this is the same identifier the IMEI number that we had taken down so you have to put identifier here like if I take it from here so it would be you have to copy from your IMEI number and you have to paste it here and you have to click the right button save button that is save button so you have if you will click it it will it will be saved so people have like are you able to do it are you able to add your device so Ananya has some problem but let us listen from Gulab. Gulab, are you able to add your device your mobile to the server? Okay, it is okay. Ananya has also added. So what is the status you see in the status? What do you see here in your case? Okay, it is online and what is last update? It is 0 minute. Okay, fine. So it means you would be seeing your location also. If you like go to the map and you zoom out, if you do zoom out, you will be able to see it would be showing the same location where you are. So here right now I'm sitting in my office and this is the Noida location. You can see this is the Noida location and I'm sitting in sector 62 and now I can zoom in and this is my actual office address. So how many people are able to see their position, the geolocation on the server side? So Ananya, are you able to see map? Okay, your location is there. Anybody else? People are able. So basically here we are sending and now if you click state here, okay, some information should also come. So if you double click your device, you will see the information here in the state. I have double clicked and there is some information has come. So what is the last packet it has received? It has received with the information. Show address, if you will click, it will so okay, sometimes it gives some error, but leave it. We are not interested. The distance 0 kilometer, like last distance is testable is 0 kilometer. Accuracy 100 meters. Speed 2.6 kilometer per hour. So here you can see what is the problem with GPS. Even if you are stationary, you can see there is a speed. There sometimes it shows the speed because everything is relative. You are stationary, but satellites and the Earth is moving, so it will show that you are in speed basically. It will assume that satellites are stationary and you are in speed. So relatively, it is showing the distance, even though you are stationary. And then the what is the last update it has done? That time stamp is also given here. What is the latitude? Total distance because it is okay. It is checking the how much distance I have traveled longitude, Battery level also, you can check your battery level, how much battery level is showing in your mobile and here on this server. So you can check, is it matching? It would be almost matching with the difference of 1%. So basically it is getting battery information. Course is, I'm not very much sure what it is. It is valid, motion, and there are a lot of parameters. What is the protocol it is sending? Altitude. So a lot of information it is being sent from the mobile client to the server. And if we make our own client, our own software, we can send more information, like we can send some more sensor data also to the server. So I hope this part. Okay, sometimes it is zero kilometer also there. So it is good. So it is not necessary that it will show always you in motion. Sometimes it will show 0 kilometer. Sometimes it can show non-zero also. So I'm saying if you see non-zero, then you should not be worried. Kn is the basically if you want to change the value of Kn, it is in I think knots. By default value comes in the knots. So if you want to change in the kilometer per hour, you have to do you have to go to the attribute and you have to change the settings. So I will tell you later on that how to change, or probably I can just now I have this information somewhere. Okay, that I will let you know. Other people are able to see this, all this information. Are they able to see state log? Okay, Gulab is not able to see state logs. So Gulab, you have to click. Basically, you have to double click your device here. The device if you double click this one, then you will see some information in the state window. Okay, so now this is the basic thing we have seen, that the information has been sent from our GPS device to the server. But here we can do many more things. As I discussed, we can create geofence, we can create like we can do some other kind of alerts we can also put. So how to do that? Let us start from there. If you go to the right hand side window, there is a setting button. You can see this circle button kind of thing. You have to go here, and you will see lot of like drop down menu here. One is accounts, groups, drivers, geofences, notification, calendar, save commands, maintenance, and logout. So accounts, you will click, you will get your account information. We will check only the relevant one, which on which we have to do the hands-on. Group is the one, it is useful for the like kind of a big transport company. Probably he is running some of vehicles in one city, in another is in another city, so he can create different kind of groups. One is running in Lucknow, one is running in Delhi, one is running somewhere else. So he can create different kind of groups so that he can properly like easily track it. Driver information he can also put, he can map the driver name, identity, other things for each and every vehicle. That is also possible. Geofence, here we are like more interested. We would be checking geofence, how to create a geofence on the server side, so that whenever somebody enters or goes out, we can get a notification. And other notification we have to do here. So basically here we would be creating the geofence and notifications, and then we have to come to the device side. We have to map this geofence and notification to a particular device. That we will do. Then there is calendar. This feature I think they have just for the reminding purpose or something. You can put some other save command, like if you have to control something on your GPS device based on some observation, like if you have to stop some operation, that you can also give using the save command. Or sometimes you have to initialize your device from the server side. That also can be done. Then the maintenance, if you have to put information about the maintenance, schedule maintenance, that also you can do. So we would be starting with the geofence first. So please click geofence button. You will see that there is one window opened here, and I already have one geofence with the name geofence 1. I will create another one also. So I will put the plus button, and here another window has popped up. Let me put it as geofence 2. So you have to give the name for the geofence. Give any name that you are comfortable. And then we have to click on the area button. There is a button area. So area is basically used to define what is the geofence area we want to cover. How do we want to define the geofence? So if you click the area, it will pop up another window. In the same window, it will open the map. And since I know that I was here, I can I can like create a geofence. So geofence can be created in multiple ways. One is polygon, circle, or polyline. So we will start with circle. Rest other things you can like try later on. So we start with circle. Since I know that I am here, I will put, and from wherever you will start, it will take it as a center. So since I know that I was around this position, I will do the right click so that it goes in the editing mode. So I have to do the right click on my mouse, and if I drag it with the left button, it will start showing a circle like this. And as soon as I'm comfortable that the circle is good enough, this kind of geofence I want up to this level, then I can stop it. I can do the right click again, it will stop here. So this is the new geofence that I have created. This is the geofence 2. So please try this thing on your setup. Let me check if you are facing an issue. Please do it. If anybody wants to repeat the step, I can do it. Gulab and Ananya, are you able to create this geofence? Okay, geofence part I have to repeat. Okay, I will do it again. So I will not save it because if I do the save button, it will save. I will cancel it so that I can do it again. I will do from the beginning. So we have to go to the setting button here. We have to click geofence here. As soon as we click the geofence, this window will pop up. We have to go to plus, and in plus we have to now write a geofence name that we want to give. So geofence 2, because one is I am already having, so I have put geofence 2. So geofence 2 I have given. Now I have to define what area I want to put the geofence. I have to choose the area. So as soon as I click the area button, probably you have followed. This is the area button here in the window area. As soon as attribute we are not touching right now. Other things we are not touching. We are just clicking the area button. So now in area, there is a left hand at the top side, left hand side. There is a drop down menu. There we can choose the kind of the shape of the geofence that we want to choose. So I have taken circle. Circle is the easy one, other one you can get confused. So wherever you can like take it this anywhere, but wherever you want to create the geofence, please put this cursor at the center point. Assume that the circle will be around the object or the GPS device uh, for which you want to create the geofence. So since I know that I am sitting here, I am putting the circle here. The I'm putting the cursor here. I am clicking the right right click button so that it can know that I have gone to the editing mode. Now I have to drag with the left click, and I have to like expand the circle till I am comfortable. So I will, as soon as I feel that the circle is good enough, the geofence is good enough, I can again click the left button and it will be stopped here. So it is little bit tricky. I Anybody able to do it? There is a juggling between left and right button if I am using the mouse. Anybody is able to do it, or yes or no? Gulab, are you able to do? Ananya, you are able to do? Anybody else who was like actively participating? Okay, Gulab is able to do it. So he has created a geofence. So now I will click the save button, the right click button. So I save. I again do the save button. Then you can see the second geofence 2 has been also created, and I can close this window, and you will see that one geofence has been created around my location. So this is my mobile, this is my device, and one geofence has been created. Now geofence has been created. Now what I have to do with the geofence? I have to again go to the settings. I have to create the notification. What kind of error are you facing, Gulab? What error is coming? Some HTML error. Okay. You can try. Have you used circle only, or you have used some other shape? Earlier, miss? When did you use it earlier? I think you have to try again. Error should not come because this is here. There should not be any conflict. I did not get. Let me like you can try again. You can try again. It should not be any issue. Uh, because here it should not be any problem. Either you have used. You can try some other geofence name. Don't use the same that you have used. Use some other name. Probably there is a conflict between the confliction happening in the geofencing name. Somebody like Ananya, are you able to do it? If you are not able to do, I can like repeat it again because this is important. You have to check it that like how it is done. Okay, Ananya is able to do it. So now I will move on further. So here we have to go to the notification. Now I have already created some notification. I can remove this notification, and so that uh, you can we can do it again. So if you click the notification, you will see this kind of window. There would be nothing inside down. We have to click the add button, and here you will see another window pop up with the type here type it, you can see lot of options are there, like status unknown, geofence exited. So we will take geofence exited. Whenever our vehicle will exit the geofence, it will show the message. The similar way, okay, yeah. So you click the geofence and click the all devices. Then channel, how you want to achieve, get the notification, we can select as a web. So all the notification will come on this dashboard. If you want to get it through mail or the Firebase, they have also Google Firebase also support they have given. You can also do that one. But right now we will do with web only. So you geofence exited, click all the devices, select the web option and do the save. You have to the save. Now for geofence exit case we have taken. Now similarly we have to do for the geofence enter. So you can see geofence enter is also there. You can select it, geofence entered, and the channel is web. So as soon as we will enter in the geofence, it will show it. And other things, there are other notifications also there. You can go through like status offline. As soon as our device is going offline, it should give the notification. Status online, as soon as our device becomes online, we should get the notification. I can take this one also. Uh, and like I can create multiple, and there would be some speed limit also there, speed limit. So speed limit exceeded, that also I can take. So it is applicable for all the devices. Channel is web, and then I have added all these 4 notification. You can do more also, but let us start with these 4 events and alerts or notifications. So have you configured in your dashboard? Ananya, have you configured the notifications? Take anyone, geofence exited or geofence entered. Okay. Gulab, you have done. Other people, please follow it up. This is very easy. Here, everything, there is no coding involved here. Only whatever components we already are having, we have to just plug it in the right way so that we can complete our this GPS based solution. So here, once all the notifications are configured, I will, I'm closing it. And now this is configuration has been done. Now we have to map it to our device. So we have to come back to the device section. Device section, you will also see again one setting button. Click this one and go to the geofence. Geofence, you will see the geofence name here, whichever you have created earlier, and you have to do the select because I have geofence 2, I have newly created, so I have to select it. Now, once you select it, after selection, you can close the dialog window. So that is one thing that geofence selection we have done. So we have mapped those geofences to this device. Now we have to go to the notification. So notification, whatever notification we have created, those are also listed here. We have to again select all of them. So all I have selected, and I will close the dialog box. So now mapping has been done, and so I will now everything is ready at our end. I will ask one of my employee to take my mobile and move little bit outside so that we can see is it when it exits from the geofence, do we get the notification or not. So the notification should come here. So give me a moment, I will ask someone. उसको अविनाश को बोल देना, उसका बाइक है. So I have asked one of my employee to take the mobile, and he will go on a bike, and he will take a round. We'll see when it exits. The device will exit from the geofence. What would happen? So similarly, you can also like. So in the meanwhile, we can like discuss anything more till the time the person is going. Please like ask. Ananya, everything is done at your end, right? And Gulab, you are still stuck with the circle making or the geofence making? Gulab, could you complete it? Gulab is saying he's invalid parameter. Okay, Gulab is saying invalid parameter or constraint violation. It is not related to network issues. There is something else. So you have tried with different name also, right? Different invalid parameter or constraint violation. Okay. Anyway, after this, okay, you can if you cannot use the same device in different login also. This is also one restriction, because once a device is registered on one email ID, it cannot be registered on another email ID. That is also one problem that you can try on another. So you have to like after this session, whenever you get time, please try to fix this issue. Okay, what kind of like okay, so see if you have moved you have to move out of the geolocation, then only the geofence, then only you will see uh, the the event. Otherwise, if you are in the same vicinity, there will not be much change. Already like your mobile is moving here and there, some uh, yeah, you cannot see much differences. And yeah. Okay, and by the time we are getting, I can show you something in the report section. If you come to the report, you can check the type of report, the kind of route. Say if you want to check the events that has happened in the past few days, so you have to select the events, click the configure button, and which device you want to check the events, click the device. So my mobiles, because the device name was my mobile, and then events, all kind of events it will show. I have mentioned all events, show marker, and period for what duration. So we want for today, yesterday, this week, previous week, month, or the previous month, or we want to have custom that it can show. So I will take yesterday, or I can take this week, so that I can show you. So since I have been using this device for last few days, you can see some activities here. So I will do, I have done OK, and I will do the show button. So here you can see my mobile was this kind of notification or this kind of events you will see that it was entered in the geofence. Which geofence? Geofence 1 it has entered at what time. So status online, geofence exited, geofence unknown. So this kind of events happened on 21st. And then in the like other days, it has captured only for yesterday only, or maybe today only. See here now my person has gone. You can see the geofence exited has immediately come. So my person has gone. So you can see the event. One event was created. The geofence exited, geofence 2. So now the person is taking my mobile and he's going this side. And you can see the update happens in few seconds, not every time. So every 10 seconds you will see the update coming. So So as soon as he will come back to this geofence, you will see again that geofence entered and geofence 2, which geofence have, because I have another geofence also that is here, geofence 1 and geofence 2. So if this device will enter in geofence 1, then it will show that entered in geofence 1. So as many geofence we can put, it can show wherever it is entry or exiting is happening, correspondingly it can show. So here now again let him come back. By that time I can show other things, like you can see the some other things like I show chart. In chart uh, we can do configure, and we want to plot the speed, that what speed I used in past trips. So I have selected my mobile. I have selected a speed. In chart, you can do other things also are possible, like battery level and other things, distance, fuel. If you have properly mapped all the information, it will show. But speed, I know that it is coming right now. So, and for this week, I selected. So see, the person is going like this. Okay, so I have done, and now I can put the show button. So it will show all the speed that I had kept uh, while I was traveling. So you can see that 21st I was traveling, then I had the speed up to 40 kilometers per hour, or sometimes I had touched probably 50 kilometers per hour. And as soon as I clicked, it is showing the path also from which I have entered. I have come from geofence 1 in the morning because this is my home. And then I took this path, and with every point, if I click, like it can show it was when I click this one, I was at this point. If I click somewhere else, like here, I was here. So it will show that way. So it will and now since this person is going, it is showing the current speed here. The last, if I show that 21st February 2 o'clock, more than like 2:11, I can see this information also here. And during between this time to this time, I was idle. I was in office. So in the morning, you can see there was some speed information, and just now because the person is going. Now he's entering. See, now he's entering. Let us see. There would be definitely there would be some lag. See, immediately he has entered in the geofence, and you can see that geofence entered geofence 2. So mobile has entered in the geofence 2. Now it is, so this way you can like it for the security purpose. If you want to track your vehicle movement that is having a GPS device, you can always know. So now that person is coming inside, and this is the thing. So when we create this kind of chart, you can like all the trip information, how did it move in the during that period, it can give all the information. So this is the basically report for the my morning trip. So there is some question, let us check in the chat window. Okay, so question is, do we have same service in GCP, Google Cloud Provider? What is it? What is its name? GCP, I don't think this kind of services they are providing. Uh, in general, they are not providing at this free version. It is not available. Maybe they have in the paid version, that I am not sure. I have never used GCP. Please repeat from taking charting option. I will repeat it again. Did I get information of my mobile with different IMEI number even if it is offline? Okay, okay, thanks. So I have got my mobile back now in my room. So the last question is, did I get information of any mobile with different IMEI number even if it is offline, you cannot get the information. It has to be online. So first of all, uh, it should be the geolocation should be on in the mobile, location update should be on in the mobile, and as well as it should be connected with any Wi-Fi network or the mobile network. Then only the connection will happen to the server. How to download the coordinate of the so here there is a possibility of sometimes they have given some export and this information. I'm not sure that which, because they keep on doing updates. Let us check daily summary. So daily summary, if we have done, we have to go to configure, and everything is done here. So I will select here. Now you can do export, and you can do email report also. So if I do export, it will download a file in Excel file. You can open it and you can see the summary. But I don't think that coordinate they can directly give. Let us see what kind of information they are providing right now. So here they have given the complete summary from 20th of February to 27th of February. They have given for the complete, okay, this week they are giving. Either we have to put the last week, then it will give more information. Here, my mobile start date is 21st February. Distance I have traveled 9.3 kilometers in morning. The start odometer was 473. The end odometer is 483. Top speed I had 60 kilometer per hour. Average speed was 1.4 kilometer per hour because I was stationary for a longer period. So that's why it is showing 1.4 kilometer. Engine hour is 0 and spent fuel is 0 because I have not mapped anything here in the. So you, as you map the information with the fuel, it will give you the right information. So this is the summary they have given. Since this is a free version, it will give a limited information only. We can check more other options. Daily summary, instead of I can check, okay, trip. Let us check trip, how many trips I have done. Configure. So this is properly this week, or I can see because it's Monday. So let us check previous week. Previous week, yesterday I had traveled to neighboring city. Let us check how it is coming because Monday it has started. It is not taking yesterday's. Now I will put show. So I have traveled this place, and let us export this also. So here, okay, start address, here it is showing some coordinates. So from which position? So if I click this one, probably it will take you to the OpenStreetMap and it will show you the location also. If I take OK, it will open the in the browser and it will show you the location where it was I had started. So I had started from this position, so it is showing in that way. So the information that is mapped, they have given the hyperlink also. It can, and this is the end address. So how much time it has taken. So like this is, we have to modify this information as per our need. So this is the default information that comes from the server. We can do, we can check few more options also. Trips other than trips. root, if I check how does it work, show. Because it has to fetch the data from database, it takes time. So this report generation is little bit slower in all the servers. So here it can show, it is showing the route. When I traveled in the last week, which route I had taken. So that kind of information is also coming. So I had gone. So this is the time period on 15th of February. It can show the address also. Wherever I was, if I click this one, I was here. So it will mark, it will give a marker. And whenever I was here, it was the stationary. Let us go. If I check the speed column, wherever I was in speed, we can check there. So this is a like huge uh, report basically. Okay, here I was somewhere in speed. I was 46 kilometer per hour. So here I was moving. So let us see that it will show where I was. It is kind of little slow, I'm thinking. So if I click this one, because here I was in speed. So when I click this one, probably the mapping is reverse way. I click this one, so it will show that at this moment I was uh, at this time 20th of February 7:44. I was here at this point, and my speed was 89.8 kilometer per hour. So this kind of information, and I can see the address also. So if I click any point, it has taken various data points and it can show that what was the details for that particular moment. So here now it will show here and it will take me to the different data point. Okay, so that way like we can check more things. So if I like zoom in, it can give like more details. Basically, I can remove this event part and it can show. So basically each arrow here you can see it is a data point. So every 10 seconds it has sent one data. So if I click any one of them, so it will take me to there. So here at this moment I was at 55.6 kilometer per hour and this was at this moment I was there. So you can see that almost every new report was 6-7 seconds it is showing sometimes, but I have set for 10 seconds, but sometimes it can show the different here. See 11 to 21, that is fine. 10 second, 21 to 28. So sometimes it sends early or it is sending at the same time, but server it is reaching little early or little late. So that is the thing. Otherwise we have set to the 10-second reporting time. Or probably I don't know earlier what was the time. So here it is showing all the way I have traveled. So all the history I can see which way I had gone. So this is very important for the fleet management people or the owners that which path their vehicle is taking. And based on that, you can make a lot of applications. Let us see more questions coming from here. Okay, how to? So I think we have covered all the things. If there is taking the chart option, so if I think you can follow, you have to go to chart and do the same process again. You have to go to configure whatever parameters you want to print in the speed or like any other parameters that you can select. But I had taken speed because that information is only available right now. We have not mapped the fuel or any other information. And then we have to select which duration you want to do, that you can select from here, and then you have to do save button, and you have to like click show, then only it will start showing, otherwise it will not show. So I think more or less we have covered the agenda of this hands-on session. So here you have seen the speed information that is coming from 15th of February to 20 of February. So here you have again seen. So it is either you take a chart for the different parameters, or you select the route, kind of information would be same. There are other things are also there. You can check stops. Let us see stops. What how many times I have taken the stop. So let us configure for previous week. If I select stops, and I have to put show button. So fetching data is little bit slower all the time. It will take little more time. So you please list down your questions if you have more. I don't know how many people were able to follow it up and they were able to perform the exercise, but everything is very simple. I will share my slides. You can try yourself at later time if you miss something. It is very easy. All the information is like mobile. Anyway, you have some of the people probably they are either on mobile and they are not having laptop at this moment, or they are on laptop but mobile should anyway with them. So you can like run this hands-on later on also. It has lot of potential. You can develop lot of use cases around it. So this was the different. Now it has come up the report. These are the different stops I have taken in the last 1 week. Here I have stopped at my office for it is showing 0 hour. I don't know why it is saying, but then the other one is another one is again okay. My office there I have stayed 111 hours in the last week, and the third one is this one, this geofence one area where I have stayed 1 hour to 1 hour 21 minutes. So probably it is the time frame from where it has started measuring. So it can give this kind of information also, that what are the steps. So like if a long trip journey is followed by number of vehicles, so what are they stopping at the prescribed spaces or the prescribed stops that is already defined by the fleet owner, or they are going some other location, or they are stopping. So this is very, very important for the owners to know. So these kind of reports are very useful for them. So that the number of stops that were given, there only drivers have stopped the vehicles, not any authorized places they have taken. Yeah, please list down the questions. There is one more question from Gulab Patel. How long we would be having the access to this cloud service? This is always available. This cloud service is always available. This is free for a long time. I have been using it since last 5-6 years. So it is available. The only thing is that they keep on changing it. The servers keep on changing sometimes. But for initial, for testing purpose, it is available. And most of the GPS service provider, they are using this open source code only, and they are developing their own servers. The another question is, and GPS, as GPS has some latency, what are the other solutions to improve the system? So this is very like tricky thing. We can improve up to some extent, but we cannot like completely remove this part, because it is totally dependent upon the number of satellites it it is coming in its vicinity. So if number of satellites are coming less, then it like anyway the delay will be more. But there are some GPS devices that are giving like more precise information. Uh, uh, so those chipsets are better than the other one. Some people claim that they can give up to say 1 meter location fix, but for that you have to have some other assisted information. Then only you can achieve. If you are totally dependent on the satellites, then it is a problem. So you have to probably get information from the nearby cellular system. Then you can do, or you have to use some other internet service provider. That information you should get, and then you should. So that way, if you have some assisted information, you can get better fix, better accuracy. So I think the time is almost up. Please ask if you have any more question, and you can write me also. I can help you probably if some people are not able to perform and they want to do further. You please take down my email address, that is kaushal@uniconversetech.in. Please write to me. If you need any kind of support, I would be happy to help you out.
So dear participants, in case if you want to interact in the session, you can raise your hands. We will be unmuting you and you can talk with the speaker.
Okay, so there is one question from Jaya Sharma. Sir, can we interface TechR app with our project? Yeah, you can do it. You can do it. There should be some exposed API also. Probably you can use. I will check, because sometime back they were using, they were providing basically. If you want to use those API, you can do it. Otherwise, at least till you are using their client, there is no issue. Uh, the APIs are required only when you have to write your own code, you have to add your own sensors, or you have to interface you have not a very standard GPS device. Instead, you are making your own solution. Then probably those APIs are required. So that is possible. Yeah. So Jaya, if you have more question, like if you start using, you start making some project and you face some issues, please write to me. I can help you, because we have used all these things like for a longer duration. So probably in the recent past we are not using this app very much, but in the past we have used quite a lot. So anyway, how much like you like this session? Like, did you learn anything? The people who could not do experiments, did you find something useful? Can you use this whole ecosystem that I had shown you in some kind of project development, or some idea that your students can work on? Okay, so Gulab is saying, yeah, he was benefited with this. I hope that everybody else who could not do the exercise, but at least they could have a feeling that what exactly we can do. There are enormous things that we can do. We can do a lot of reporting and other things, and everything is ready to use. At least the students from the first year, second year, they can start making something. And the third year, fourth year students are expected to create their own GPS device. But the first year, second year, they can use their own mobile to do this kind of integration. Okay, thank you, Jaya. she also liked it. Yeah. Yeah, okay. Manish is also saying that he has understood. So I hope each and everyone would have been benefited, and I will share my slides. Please go through with them. And whoever were not able to perform the hands-on, please do it during your idle time, during the weekend or sometime. Okay. So, okay, Prasunna sir is also like saying it is very informative. Okay, ma'am. So now we are done because we are running out of time. So shall we conclude this session?
Thank you, Kaushalendra sir. So most of the queries of all the participants are being answered. So thank you, sir. Thank you for this wonderful session. So with this, we come to an end to the hands-on session of day 6 of 2-week online faculty development program on IoT. So tomorrow we will be meeting again at 10 o'clock. So we request all the participants to be active. The link will be remaining the same for tomorrow also. Also, there is one announcement from our end. We request all the participants to please refer to the YouTube channel. The YouTube playlist of this course is already being provided to you. All the day-wise videos are uploaded in that playlist. So in case if you want to refer to the course content of the entire day, you can refer to those videos for hands-on session and also for lecture session. The PPTs will be uploaded as the course progresses. And last but not the least, we would like to request all the participants to check your name spelling and your institute spelling and details, because these two details will be reflected in the certificate. So once the certificate is issued, it will be very difficult for us to correct. So we request all the participants to please provide the correct details beforehand. That's all from our end. Thank you. Thank you, Kaushalendra sir. On behalf of the course coordinator, Professor Ratnaji Bhattacharya sir, I thank you for joining today and conducting this hands-on session.
Okay.
Thank you, sir.
Okay. Yeah. Thank you, ma'am. Thanks everyone. I hope that you enjoyed this session. Please have a nice day. And in case of any question, you please contact me without any hesitation. Okay. Thanks everyone. Okay. Bye.
Okay, bye, sir. Thank you, sir. So, dear participants, thank you all for joining and making this day 6 of the program so successful. So, we request all the participants to please disconnect from their end. The meeting link will be deactivated in another 2 minutes. Thank you.